Okay, so let's begin our discussion, no? So, let's have a review. Ay, ba't na full screen to? Ayan. So, let's have a review of your Gen Chem, specifically the atomic orbitals, no? So, what do we know about atomic orbitals, no? This is a representation of how electrons are distributed in an atom, no? So, before kasi magkaroon tayo ng idea ng atomic orbitals, they thought that the electrons are embedded in the nucleus itself, no? That's the plum pudding model by J.J. Thomson. Then later on, that developed into the nuclear model, no? Yung kay Rutherford, where the electrons are moving around the proton and the neutron or the nucleus, no? So electrons are moving around the nucleus now. Then that was further enhanced by Niels Bohr, no? So according to Niels Bohr, the electrons orbit the nucleus, no, at certain energy levels, no, and when they jump from one energy level to another energy level, then there is a release or absorption of light, no. Kaya kung mapapansin nyo sa fireworks, bakit kaya kulay orange siya? Bakit kaya kulay yellow tong kaputok na to? That's because of electrons moving from different orbitals, no? Okay, so the fire, the heat energy excites the electron, and as that electrons relaxes, no, after their excitation, pag nag-relax sila, they go back to their original energy level. Hence, may nare-release ding color, no? Ayan, nawala rin. So, ayan. So, that's the idea, no? So, that's the atomic orbitals. Wait lang natin ulit si Rika. Ayan. Kasi, di ko alam kung converge din si Rika, no? Kasi, recently sa Valenzuela, we're having connection problems, no? Especially for converge, no? Kagaya kanina. Bigla nawala internet ko. But anyway. Sige, continue na lang tayo. No?
Sir, nawawala-wala daw po yung net nila. Simula pa daw po kanina.
Sabihin, converge ba siya kamo?
Wait lang pa.
Kasi converge din ako eh. Nawawala din siya kanina, as in. Yan, online na si Rika. Ayun. Rika, converge ka ba?
Sabihin mo bakit?
Nakadate lang po.
Ha?
Nakadate lang po ako.
Ano yung ano mo? Internet?
Nakadata lang po.
Data lang. Kasi kung converge ka, feel ko rin yung nawawala yung internet. Grabe talaga yun.
Nagka-problema po kasi yung wifi namin eh.
Hmm?
Nagka-problema po yung wifi namin, kaya po nakadata po ako.
Sige lang. Medyo matipid naman yung Teams sa data. Si yesterday, no, yung lahat ng klase ko naka-mobile data ako. So, it consumed less than 2 gigabyte naman, no, for several hours of classes. Yan. Anuhan na lang natin to, no. I-chill na lang natin yung approach natin dito para bilis din tayo matapos, no, para tipid sa data. But anyway, that's the idea, no. So according to what I said earlier, the idea of atomic orbitals originated from the understanding of how electrons are where are the electrons in an atom, no? So yun. So it started from the idea that electrons are embedded on the surface of the nucleus, no? That's the plum pudding model by J.J. Thomson. Then that was improved, no, into a nuclear model by ano nun, si Ernest Rutherford, no? So according to Ernest Rutherford, that electrons are moving around the nucleus, no? So hindi na siya naka-embed, umiikot na siya sa gitna, no? Then that idea was further enhanced by Niels Bohr. So according to Niels Bohr, that electrons use certain energy levels, no? And each energy levels may result in different properties, no? Such as the colors of your atom, no? So, ano, may fireworks, iba-iba yung colors nila. That's because of the different energy levels of electrons, no? So, kunwari may tumalon na electron from energy level 1 to 3, then bumalik sa 1, no? So, each jump ng electron that corresponds to a different wavelength of light, no? Kaya we see different colors every day, no? So, ganun yung idea. Then, with the idea of Niels Bohr, no, na panganak ngayon yung idea ng quantum mechanics, no. So, si Niels Bohr ang naging key person to develop the quantum mechanics, no, which is involved na sina Erwin Schrödinger at iba pang mga friends niya, pati yung kanyang pusa, no. So, what they found out with their quantum mechanics is that they came up with a mathematical expression that describes the distribution of electrons, no, in an atomic system, no. So meaning ng equation para siyang curves, no, kagaya nito, no. So there is an equation, no, for different types of wave functions. So ano lang meaning ng mga terms na yan, no? So meaning lang yan is that for every energy levels, for every orbitals ng electron, they correspond to different shapes, no? And kung isipin natin, saan kaya nanggaling yung shape na yan, no? Yung statistics na yung bahala dyan, no? Kasi yun, no? So statistically speaking kasi itong mga shape, no? Para siyang yung Gaussian curve, no? If you're familiar with the Gaussian curve,
Sir, nawala ka.
oo nga eh. Di ba ako na may nawala? But anyway, so yun nga sabi ko sa inyo, no? Na yung shapes na itong circular, itong dumbbell shapes, no? These are defined by statistics na lang, no? So yun. What they did is that they use the equations given by the quantum mechanics, no? Yung equations per different energies, no? So yun. Clean up nila yung equations na yun, then they came up with different shapes for different orbitals, no? Okay, so ano ba yung mga orbitals na yun? Yung s orbital, the p orbital, the d orbital, f orbitals, so on and so forth, no? So what they also found is that since there is now an idea then, no, kasabay nito yung idea that particles, no, yung light, no, it exists as waves or particles, no. So the same thing is true for electrons, no. So electron is a particle and is also a wave, no. So parang yun yung idea, no. So yun. So similarly, like photons, electrons behave as particles and waves, no. So therefore, yung behavior ng electron as a particle that can be observed using these shapes, no. So, andyan yung mga electrons sa shape na yan, no? So, andyan yung mga particles natin. So, ano naman yung as waves, no? So, if electrons are to be treated as waves, then they should follow this wave wave diagram, no? So, yan. So, meron daw pa up, meron pa down, and may nodes, no? So, ano lang meaning ng mga yun, no? So, sometimes electron is positive in value for the wave function, minsan negative, minsan wala, no? Okay, so saan ginagamit yung ideas na yon? Mamaya, no? Kasi mas maganda makita natin siya as a whole picture na, no? Pero yun, binigyan ko lang ng idea. So, electrons can behave as particles, no? They can clump up to form different shapes, no? And they also behave as waves, no? In such way that we can use this idea, no? If naka-form ba siya ng bonds, no? So, mamaya makikita natin yan, no? So, yun. So, again, as a particle, may shape siya. As a wave, no, we can predict kung may bond na ma-form, no. Pero yun lang yung idea, no. Dami ko nung talaga sinasabi. So yun, what else do we know, no? That different that different atomic orbitals have different energy, in which the 1s orbital is the lowest among all the other orbitals, no. Ito yung mga 1s2, 2s2, 2p6, no. Yun lang, yun lang yung other way to say that, no. That 1s orbital is the weakest, or the least energetic among all the energy orbitals, no, or the atomic orbitals out there. That is followed by 2s, no. And then we have the 2p orbitals, no, which have three different orientations in space. Because if you can remember, no, in describing quantum numbers, we have four numbers. The principal quantum number tells you about the energy level. The ano ito, N pati L, no? The azimuthal quantum number tells you about the shape, no? The magnetic spin quantum number ay yung plus 1/2 minus 1/2, no? And the ML, no? About orientation naman yun, no? So, ano yung mga orientations ng ating electrons? So, yun, it could be on the y-axis, it could be on the x-axis, and it could be on the z-axis, no? So, yan. So, yan lang yung idea, no? So, different orientations, different shapes, no? For each orbitals, no? And what else, no? Yun lang. Ano pa ba yung sinasabi dito? Ayun, and the feeling of electrons, no? The feeling of energy orbitals is still governed by the three rules that we use in Gen Chem, which is the off-bow principle. When we say off-bow principle, that tells us that we feel first the lowest energy orbital, which is 1s for our case. No? So you can see here, we have hydrogen, we have one electron for hydrogen. So it only fills the 1s orbital muna. No? Then for helium, since 2 electrons siya, yun, it can complete the 1s orbital. No? Remember that for each orbital, it requires 2 electrons. No? What if 3 na yung electrons? No? So it will fill up first the 1s orbital followed by the 2s orbital. No? Then after mapuno ng 2s, yung 2p orbital will follow. Then later on, the 3s orbital, the 3p orbital, no, so on and so forth, no. Pero we will not go into that further kasi Gen Chem na siya, no. Basta ang idea lang natin that electrons are filled up in accordance to off-bow principle, that electrons fill the lowest energy first, no. So mauuna muna yung 1s bago yung other orbitals, no. Pauli exclusion principle that only tells us na there should be no two identical quantum numbers, no? Meaning, kapag yung isang electron daw ay pataas in shape, ito yung positive na sinasabi natin kanina. If it is positive in wave function, dapat yung kabila ay yung negative naman yan, no? Negative 1/2, no? So, yan. Isang pataas, may isang pa down, no? So, they can form the bond, no? So, di pwedeng parehas pataas. No? Because of, ano mangyayari pag parehas sila pataas? There will be a repulsion sa charges. No? So, yun. Yun lang. Off-bow, you start from the lowest energy orbital pataas. Poly, yun nga. there will be no two quantum numbers that are the same. That means, kailangan may electrons na pataas, may electrons na pababa, no? So, yun. Pero hindi natin ito i-discuss ng malalim na. Hund's rule, yun nga, when filling orbitals, no? For example, sa 2p orbitals, no? So, how do we fill the 2p orbitals first, no? So, ginagawa natin, no? We fill out the energy orbitals one by one muna before completing the pairing, no? So, what I mean by that is, kunwari, I have 3 electrons, no? Hindi ko siya i-clump na 1, 2, 3, no? So, hindi ganun, no? Instead, I fill out first each orbitals found in the p orbital, no? Suborbitals na found in the p orbital. So, isa-isa daw muna siya, no? So, hindi mo pwede i-compule lahat ng 3 electrons dito sa dalawang box, no? Instead, isa-isa muna punuin. Yan, lahat muna pataas. Then, pag may tigi-isa na lahat, what's next is that yung pababa naman, no? To complete the pairing, no? So, yun lang yung idea niya, no? Okay, so, kwento lang naman yun, no? But in organic chemistry, we are more concerned, no? Not with the atomic orbitals. Kasi that is something that we know already, no? And what we are more concerned with is the molecular orbitals, no? How atomic orbitals behave when they create molecules, no? Okay, so ito yung nangyayari. So, what happens is that if you are making a molecule, you have 2 atoms combining to form a molecule, what happens is that they mix their properties, no? Pinaghahalo nila yung orbitals ng isang atom at ng isang atom, no? So, pinagsasama nila yan. Ito yung isang atom, ito yung isang atom, pinagsasama nila yan to form this so-called molecular orbital, no? Okay. So, yan. Kunwari, may dalawang atomic orbitals. Yung isa sa isang hydrogen, yung isa sa another hydrogen. Ang ginagawa nila, again, they fuse it into one big molecular orbital, no? Okay. So, kung mapapansin natin, no, yun nga, sabi natin, we said that when we create molecules, we combine their atomic orbitals, no, to form the molecular orbitals, no. So, yan, pinagsasama natin yung 1s, 1s to form this molecular orbital, no. So, kwentuhan natin yan, no. Okay. So, when we have a molecular orbital, as you can see, di ba, una parehas sila, pantay sila ng energy. Ayan, pakita natin. So, they started with the same energy, pero when they mix their orbitals, nagkaroon ng split, no? Ang nangyari is that mayroong orbital sa baba, mayroon ding sa wala na naman ako. Saan ako nakatapos? So anyway, so balikan ko na lang uli yung sinabi ko kanina. No? Okay, so ano uli nangyari? Diba, sabi natin, when atoms form molecules, they form molecular orbitals. No? Take for example, hydrogen gas, H2. Ito yung unang atom, ito yung kanyang atomic orbital. Ito yung katabing atom niya, ito yung atomic orbital niya. Then, ano ginagawa? Sabi natin, we combine those atomic orbitals to form these molecular orbitals. Then, as you can see, nag-split ang ating atomic orbitals. No? Nag-split siya into 2 different orbitals. Yung nasa baba, that's bonding orbital. Yung nasa taas is the anti-bonding orbital. No? When we say bonding orbital, dun mafo-form yung bonds, no? Pag anti-bonding orbitals, hindi mabubuo yung bond, no? Okay, so, ano lang meaning nun, no? Okay, so, when we have bonding orbitals kasi, the energy is lower, di ba? So, ibig sabihin, the formation of bonds is favorable, no? So, ibig sabihin, pwede sila magbuo ng bond, no? Hence the term bonding, no? Pero if yung electrons, no, it can reach the anti-bonding, no? Kunwari, there's a lot of electrons. Sobrang daming electron. Ang nangyayari, yung electrons, sila mismo, yung nagkokontrahan din sa isa't isa, no? And what I mean by that is that napupuno nila yung bonding orbital, then yung sumusobra, napupunta sa anti-bonding orbital, no? So what happens is that kapag itong anti-bonding orbital ay nabuo, no, nakompleto nila yung electrons dyan, hindi mabubuo yung molecule, no? So our goal in organic chemistry is to just form bonding orbitals, no? And not to reach the anti-bonding orbitals, no? Dito rin pumapasok yung idea ng electrons as waves, no? Okay. So what do we know about waves, no? What we know about waves is that, di ba, ang alam natin, there is a constructive and destructive interference, no? Dito din yung pumapasok, no? Yung electrons, if they are constructive in nature, no? Constructive in nature meaning iisa sila ng phase, no? So, they can form the bonding orbital, no? So, iisa sila ng characteristic, kunwari, no? Pero kapag marami ng electrons, ibig sabihin may nagkakaiba na ng mga characteristics, no? May nagtutunggalian ng electrons, they can form the destructive interference, no? Okay, ang destructive interference, ang meaning lang nun is the anti-bonding orbital, no? So, yun lang. Ito yung sinasabi ko kanina na wave idea about the atomic orbitals na. So, yun lang. So, summarize uli natin yung slide, no? Para maka-move on tayo sa susunod na slide. In summary, atoms combine their orbitals to form molecular orbitals. What else, no? When they form molecular orbitals, we create two different sections, no? Na paghihiwalay natin yung mga orbitals. We can have an orbital with low energy. We call that the bonding orbital. And the orbital with higher energy, yun yung mga anti-bonding orbital, no? When bonding orbital is formed, no, is filled, no, dito nagkakaroon ng chemical bonds, no. Pero kapag na-reach niya at napuno yung atomic orbital sa anti-bonding, no, so pag na-reach niya yung anti-bonding orbital, hindi mabubuo yung molecule, no, because there is a destructive interference among the properties of electrons, no. So kailangan ang goal natin is just to reach the bonding orbital, no. So yun lang. Pero ito, kwento pa, side note lang, no? Itong shape na to, itong orbital na to, this actually allowed, no, chemists and physicists to identify whether an atom or a molecule is magnetic or paramagnetic, no? Yung paramagnetism and diamagnetism. So dito rin yung na-discover, no, that when they feel electrons, no, or when they feel atomic orbitals, then paired sila, edi para magnetic, no? Parang magnet. So, pag hindi naman, edi dia, no? Hindi magnet. So, yun lang, share ko lang. Pero yun nga, no? So, ang gusto lang natin makuha dito, again, no? Ano yung gusto natin makuha ang idea? Ulit-ulit ako, no? Ang gusto ko lang i-emphasize, no? So, gusto ko lang i-emphasize that the idea that we should get here is that atomic orbitals form molecular orbitals when making molecules. Dalawang parts sila. We have the bonding, lower in energy, anti-bonding, higher in energy, no? Okay. So when electrons behave in a constructive manner, meaning nun nag-agree yung mga properties nila, no? So they can form bonding orbitals, no? Pero kapag sobrang daming electrons na, what will happen is that yung ibang electrons mapupunta dito sa anti-bonding orbital, no? So yun. Kapag ito napupuno, then nagkakaroon ng destructive interference. So, nasisira yung molecule. Hence, the molecule will be impossible to exist. No? So, yun lang. No question. Okay pa naman. Ang daming kwento, no? O, clarification. Wala pa naman. Since wala pa naman, no, magtatanong ako, no? Question muna para check natin yung comprehension. So, when we create molecular orbitals, we create two different sections, no? Dalawang distinct sections ng molecular orbital. Yung nasa baba, lower in energy level, we call that the
Bonding orbital.
bonding orbital, no? So when electrons fill the bonding orbital, the formation of chemical bonds is possible, no? Pero kapag kunwari sobrang dami ng electron, saan mapupunta yung sobra? Sa yung nasa taas, no?
Sa taas po.
Oo. Ano yung tawag sa nasa taas?
Anti-bonding.
Anti-bonding. So yun. Pag sobrang dami ng electron, no? Yung ibang electrons na pupunta na dun sa anti-bonding orbital. So, pag andun, hindi na mabubuo yung molecule, no? So, saan may constructive interference? Sa
Low.
sa low, yun sa bonding, no? Pag destructive, sa
High po.
sa anti-bonding or sa high orbital. No?
Anti-bonding.
So, yun lang yung gusto kong idea na i-share, no? Yan. Pag tinuloy pa kasi natin to, magiging inorganic chemistry na tayo. Pero, kwento lang natin, no? Para organic chem pa rin tayo. Okay, so what else, no? What else do we know about, about atoms, no? Sige. Looking at carbon, di ba si carbon, ang kanyang electronic configuration, palitan ko ng color yung part. Ayan. So, when we write the electronic configuration for carbon, since may 6 electrons yan, 1s2, 2s2, 2p, 2, di ba? Ayan na. So, yan. So, ito yan. Given yan by this graph, no? Okay. Sige. So, that means, no, the 1s orbital is filled, the 2s orbital is filled, and the 2p orbitals are not filled, no? Okay. So, by judging, no, by just looking at the 2p orbitals, no, kailangan, ano gawin ni carbon? Kailangan mag-accept siya ng 4 electrons, no? So, ano yung mga 4 electrons na yon, no? Yung 4 electrons na i-accept niya from different atoms, yun yung pupunan ng pagkukulang niya dito, dito, dito at dito, no? So, yan. Doon mapupunta yung 4 na electrons na kulang si carbon, no? Yung tatares sa kanya, yung pupunan ng kanyang pagkukulang is yun. Doon niya ilalagay yung mga electrons sa 2p orbitals, no? But, filling the orbitals in this manner, na magbibigay ka ng up electron and down electron, medyo mahirap to gawin, no? Yan. So, mahirap magpuna dun sa bagay na wala pang laman, no? So, ang ginagawa ni carbon, for it, no, to be able to form chemical bonds better, no, para mas mapabilis na yung process niya, no. So, anong ginagawa niya, no? So, looking at the 2s orbital, no, di ba, dalawa electrons yan. Ang ginagawa niya, para mas mapadali yung kanyang bonding with other atoms is that it excites the electron. So, the electrons here can go up to the 2p orbital, no. So, sinishare niya yung electron niya sa 2s papunta sa 2p, no. Kasi in such way, no, possible na mas mabilis yung formation ng chemical bonds kay carbon, no. So, ganun. So, isipin nyo na lang parang may mga slots, no? May katandem na. Parang nag-aantay na lang ng kapartner itong mga orbitals na to. Kasi kapag bakante pa yung isang orbital, medyo mahirap yun, no? Mahirap punan daw yun, sabi nila, no? So, yun. So, ginagawa, again, ano ginagawa ni carbon? So, yung isang kanyang electron dito, pinapatalo na sa 2p, no? So, sabi niya, uy, punta ka doon. Ayan. So, since meron na tig-isa, no? Pwede na sila tumanggap ng kapartner from different atoms, no? That process is called the hybridization, no? When we say hybridization, that is the modification of your atomic orbitals, no, to allow bonding to happen, no, para maging faster yung formation ng chemical bonds, no. So yun, so ito yung hina-hybridize niya, no. So itong 2s orbital niya, ginagawa niya, pinapamigay niya sa 2p orbital yung isang electron para mas mabilis yung formation ng chemical bonds, no. Again, the modification of atomic orbitals is called the hybridization, no? Or the hybridized atomic orbitals, no? So, yun, no? And yun din, no? Habang nangyayari yung, yung hybridization, di ba? Mapapansin nyo, yung electron dito, pinapunta niya dun sa 2p. What happened is that, ang ginagawa din ni carbon atom, no? Is that ginagawa niyang degenerate yung mga nagsama-samang orbital, no? Ano meaning na nagsama-samang orbital, no? So, kung mapapansin niyo, may energy gap, diba? Mas mataas yung energy ng P kaysa sa S, no? So, medyo mahirap yun kapag gagawa ka ng band, no? Kasi ang daming energy na kailangan. So, ang ginagawa ni carbon is that it makes its life easier, no? Pinapadali niya yung buhay para sa mga ibang atoms para makipag-pair sa kanya, no? Okay, so as it hybridizes its atomic orbital, meaning nun, minomodify niya yung contents ng kada lines niya dito, no? Habang minomodify niya yung isa't isa dyan, so, minomodify niya yung box na to, minodify niya yan, minodify niya yan, minodify niya yan, no? So, as it modifies the arrangement of electrons, no? Ano pa yung ginagawa ng atom, no? Ginagawa niya ring degenerate yung orbitals, no? When you say degenerate, same energy, no? So, ano ginagawa niya, no? Kung mapapansin nyo, itong 2p, mas mataas kaysa sa, mas mataas yung energy niya compared sa degenerate orbitals, no? So, yun. Si carbon talaga yung nag-adjust, no? Para lang may makapartner siya. Parang ganun yung idea, no? So, in-adjust niya yung electrons niya, binabaan niya pa yung energy niya, no? Parang pag lumalandi lang, binabaan mo pa yung standards mo para lang may kapares kang ibang atom, no? So, ganun ganun din ginagawa ni carbon, no? So, it rearranges its electron and it lowers down the energy to form degenerate orbitals, no? So, as it formed degenerate orbitals, ayun, then the formation of chemical bonds with different molecule is now possible, no? Summarize natin kung ano yung nangyari. Ano uli yung nangyari bago tayo mag-proceed sa future topics, no? What happened is that this is the original atomic orbital, no? Tapos ano ginawa natin? So, for carbon, to form chemical bonds with other atoms, no? So, kailangan niya mag-adjust in such way that it would be easier for other atoms to pair with carbon. So, yun. So, paano niya ginawa yon? Nag-rearrange siya ng kanyang atoms, ay ng electrons pala, no? So, ni-rearrange niya yung electrons niya sa kanyang orbital, and the process is called the hybridization, no? Also, as it rearranges the electrons in its atomic orbitals, ano ginagawa niya? So, pagka-rearrange niya, binababaan pa niya yung energy, no? To form degenerate orbitals, no? So, meaning ng degenerate, equal energy, no? So, yan. Same sila ng energy para madali mapunan yung mga pairs na yan, no? So, para may apat na kumabit na kay carbon, no? Para mas mabilis yung bonding process, no? Okay. So by the way, this is observed, no? Itong idea na to, this is based on observations na on how carbon behaves, no? So yan. So nag-exist na siya, in-understand lang ng mga tao before na ay ganun pala yung ginagawa niya, no? So siya yung nag-a-adjust, no, to form chemical bonds, no? So yan. Also, as it forms the degenerate orbital, there is no longer a distinction between the S and the P, no? Ibig sabihin, hindi na magkaiba yung S and P orbitals, no? E di ano na yung nangyari, no? Nag-mix na yung kanilang behaviors, no? So meaning yan, yung S and P nag-combine to form sp3 orbitals, no? Yung isang box dyan, yung galing sa X, S. Yung isang box dyan, galing sa P. Tapos yung isa sa P, yung isa sa P, no? Ito yung tatlong P. Ito yung isang S, no? So, yun, no? So, hindi na magkaiba yung identity ng orbitals, no? Kasi pinagsama-sama na niya, no? Yan. Para mas madali makipag-bond, no? Okay. May question kayo? Or may gusto i-clarify? Baka nagulat kayo sa idea, no? So, summarize lang natin yung idea ulit, no? Para mas madali ma-check nyo yung mga notes nyo kung okay, no? So, ano uling ginagawa, no? So, ginagawa, carbon modifies its atomic orbitals, no? To allow the combination or to allow the formation of chemical bonds with other atoms. Okay. So what happens is that carbon excites one electron to the p orbital, and after that excitation, no. So excitation yung pinatalo niya yung isang electron sa kabila. After the excitation, what happened is that ginawa niya that these orbitals are degenerate na. Pinagsama-sama na niya yung properties niyan to form the four degenerate orbitals, no. What else, no? Sabi ko nga, yung properties niya, pinagsama-sama. So, it is no longer 2s or 2p, but instead, we call each orbitals, no? The sp3 orbitals, no? May isang s dyan, may tatlong p dyan, no? Pero yun, the idea is, pare-parehas sila ng energy level, no? So, yun. Okay pa naman kayo dyan?
Yes po.
Baka may hindi clear, sabihin niyo lang, Okay pa naman? Okay. Sige, proceed tayo, no? More on, ano na naman to, backstory, no? Pero yung application, yung mas focus tayo. Mamaya alamin natin yung mga applications. Okay. So, the sp3 orbital, no? Ito na yung product ng hybridization ng orbitals ni carbon, no? 'Di ba, nag-hybridize nga siya para mas madali makagawa ng bonds, no? Ito yung itsura niya, no? Okay. So, ang itsura ng apat na orbitals as a whole ay ganito, no? Ayan. So, it forms tetrahedral shape, no? So, yun. So, ito yung isang sp orbital, ito yung isang sp orbital, ito yung isang sp orbital, ito yung isang sp orbital. And as you can see, no, zoom natin, ito yung mga tigi-isang electron sa kada orbital, no? Ay, teka lang, asan yung laser? Yun. So, ito yung tigi-isang electron kanina sa isang orbital, no? So, yan, isang electron, ito yung isa, yan yung isa pa, ito pa yung isa, no? So, the existence of those, single electrons, no? So, since meron tigi-isang electron dun sa mga orbital shapes na yan, no? Mas madali na makipag-pair siya with different atoms, no? For example, si hydrogen gusto tumabi doon. May isa na dyan, tapos ito may isa pa siya. Pwede na nila pagsamahin yan to form the chemical bond here, no? So, ganun din dito. Ganun din dito, and ganun din doon, no? Kasi kung hindi yung ginawa ni, pag hindi yung ginawa ni carbon, hindi siya nag-hybridize ng orbitals. Siguro, kunwari, ito, walang electron na available dyan. So, hindi makakapasok yung, hindi makaka-form ng chemical bond itong isang atom dito sa side na to, no? So, hindi kasi daw ganun yung nangyayari in nature. Instead, ganito daw yung nangyayari. That carbon rearranges its orbitals, no, to form sp3 orbitals to make it possible for different atoms to bond with it, no. Okay. And consequently, yung shape niya is the tetrahedral shape, no. So, yun. Para siyang triangle, no. Daw yung shape ng molecule, no. Okay, so yun. So, yun lang. Ayun, so emphasize natin ha. Emphasize natin that kasi kung hindi niya in-excite yung isang electron doon, edi hindi possible yung formation ng isa pang chemical bond dito. So, X to. Pero ang alam natin, hindi yun yung nangyayari sa nature, no? Carbon doesn't form just 3 bonds, no? It forms 4 bonds. So, ito daw yung resulta ng hybridization. The modification of the atomic orbital, the lowering of energy, producing degenerate sp3 orbitals, forming this tetrahedral shape for carbon atom. So, yun yung general idea. No? Okay. So, going back, no? Okay. It is also observed that yung carbon natin, no, sometimes, yung kanyang orbitals na in-excite, no, hindi naman pala niya daw ginagamit lahat, no. So, pag hindi ginamit ni carbon yung lahat ng electrons niya, na mga in-excite niya, so, that results to a formation of double bonds and triple bonds, no. Ito, nakita kasi nila to in nature, so they tried to explain. Diba, remember that yung isang electron dito, pinatalon niya papunta sa 2p orbital, no? Pero, instead daw na gamitin ni carbon lahat iyon, ang ginagawa niya lang daw is sometimes, no, there are instances that only 3 of them are used to form degenerate orbitals, no? The other electron is not used, no? Okay, so yun. So, yun. Ito sometimes, no? So, pwede daw lahat yan gamitin niya to form chemical bonds, no? Hence the tetrahedral shape for carbon. Pero there are also instances that yung tatlo lang yung ginagamit niya for chemical bonding, no? And this explains why carbon sometimes form double bonds, no? So, yan. So, kapag itong tatlo na to, nilower niya yung energy, it forms 3 degenerate sp2 orbitals, no? So, yung isa dyan, ito yung S, no? Tapos yung dalawang P, ayun, no? So, sp1, sp2, no? So, yan. Tapos yung isa pong P orbital na hindi niya ginamit, edi nasa B orbital lang siya. So, yun. So, yun lang yung idea, no? Okay. So, tingin tayo ng isang shape, no? Okay. So, ganito yung itsura. This is the shape of your carbon atom if it is sp2 hybridized, no? Meaning, tatlo yung gagamitin for bonding. Asan yung tatlong yon? Ayan, isa, dalawa, tatlo. Then, the other unused orbital, yung nasa p orbital, yun yung itong nasa pataas na to, no? So, hindi siya gagamitin to form direct chemical bonds, no? So, hindi siya maka-form ng direct chemical bond dyan, no? So, pero paano siya naka-form ng double bond, no? So, mamaya pakita natin. So, basta yun yung idea, no? That yung atoms dito kakabit, no? So, ano yung purpose ng p orbital, no? So, siguro yun yung tanong nyo. O, ito na. Dito na tayo, no? Okay. So, sabi natin kanina, no? That the 3 sp2 orbitals, ito, at ito, that is used to form chemical bonds with different atoms. Dito sa side na to, nakipag-pair siya with hydrogen. Dito sa side na to, nakipag-pair siya with hydrogen. Dito sa side na to, nakipag-pair siya with carbon. Ngayon, you may ask, ano ginagawa ng p orbital? Okay. So what happens with p orbital is that ganito yung ginagawa niya, no? Yun, nakikipag, ano na siya, tumatabi siya with the other p orbital sa kabilang carbon, no? So, parang ano siya, parang dalawang balon na pinagdikit mo siya. So, ano nangyayari pag pinagdikit mo yung dalawang balon, no? So, yun. So, what happens is that pag pinagdikit mo daw kasi yung mga electrons dyan, no? They form also chemical bonds, no? Pero hindi nga lang direct, no? So, when I say direct kasi, yun, head-on contact yung orbitals mo, no? So, kumbaga, ito yung shape, ito yung, ano, sp2 orbital. Yun, head-on yung collision nila. That means, dulo sa dulo yung connection. But for p orbitals, what they do is not the head-on bonding, no? Hindi siya yung direct bonding, kundi yung indirect bonding in the form of sideway overlap, no? Ayan. Tawag natin doon, sideway overlap, no? So, yun. So, nagdidikit lang sila. Then, yung pagdikit nila yun, may interaction yun, no? So, yun. So, yun lang. It doesn't directly connect to the atom, no? Nagko-connect siya sa p orbital ng kabilang p orbital, no? Kasi kung mapapansin nyo, yung sp2 orbitals, direct na nakakonekta sa atoms. Ayan, kay carbon, kay hydrogen, kay carbon, kay hydrogen, kay carbon, kay carbon. So there is a direct bond from one atom to another. But what p orbital does is that yung p orbitals, they just interact with the other p orbital, no? So, hindi siya interaction ng atom sa atom. Instead, no, interaction siya ng p orbital to p orbital, no? So, yun. So, again, summarize natin, no? So, summarize natin. So, what happens is that sometimes, no, carbon do not use up all the orbitals it hybridized, no? So there are instances that it will not use this orbital. Instead, gagamitin niya tatlo lang. So, ang ginagawa niya dito sa tatlo, it forms the sp2 orbital, the degenerate sp2 orbitals. These orbitals are used to form direct bonds with the other atom. No? Ito yung kumokonekta directly sa kabilang atom. How about the p orbital, no? So, yung p orbital, nakikipag-connect naman siya with the other p orbital, no? So, orbital to orbital yung ganap dito. Ang sp2 orbital naman ay atom to atom yung dugtungan, no? Okay. Sir, paano nagkaroon ng double bond dyan, no? Sige, kumari yan. Paano nagkaroon ng double bond? So, ito yung first double bond, yung carbon atom to carbon atom. Then, yung double bond, mag-exist yon as the interaction ng p orbital and p orbital. So, ayan. So, ayan. Nagdudugtong yung p orbital sa p orbital. Nagdudugtong yung carbon atom sa carbon atom. So, between carbon 1 and carbon 2, may dalawang bonds, no? Okay? So, ibig sabihin, dito sa molecule na to, yung isang electron dyan, for example, itong electron sa baba, yung electron na sa baba na yan, that is the atom-to-atom connection, no? Ang tawag pala natin sa atom-to-atom connection, we call that the sigma bond, no? So, yan. So, ito yung mga atom-to-atom connection niya. So, yan. Ito, atom-to-atom yan. Atom-to-atom yan. Atom-to-atom. Atom-to-atom. We call that the sigma bond, no? Pero yung p orbital to p orbital, yun yung isa dito, no? So, we call the p orbital to p orbital interaction as the pi bonds, no? So, yun. So, again, summarize natin. Take down notes nyo na lang, ha? Kasi, ang application nito hindi naman ganito ka-complicated. Dali lang yung application niya. Napakita lang natin yung mga, bakit ganun, no? Ba yun? So, mga ganun. So, again, pag atom to atom yung connection, we have sigma bond, no? Sigma, basa dyan. Pero, kapag p orbital to p orbital, p orbital to p orbital, we call that the pi bond, no? And the existence of pi bonds, that translates to double bonds or triple bonds, no? Pero kapag single bond, yung mga bond na na-form ay atom to atom, no? For example, itong sp3 hybridized atom, no? O kung titignan natin itong mga sp3 hybridized carbon, no? So, nangyayari is that all the orbitals, no? All the sp3 orbitals form atom-to-atom connections. Si carbon na to, connected to that carbon by this sigma bond, no? Itong carbon na to, connected by the hydrogen atom there in the form of this sigma bond, no? Same goes for this part of the molecule and this part of the molecule, no? So, yan, no? So, mga sigma bond yung mga yan, no? That's why walang double bonds kapag CH4 yung dinodrawing natin, di ba? Pero yun nga, pwede rin naman magkaroon ng pwede rin naman hindi niya gamitin yung p orbital niya to form pi bonds, no? Ito yung mga sigma bond, no? Carbon to hydrogen, carbon to hydrogen, carbon to hydrogen. So, single bond yung katumbas ng mga yan. Ano yung double bond yung katumbas, no? Kapag nag-interact yung p orbital sa p orbital, no? Okay. So, that's why we draw this molecule, no? Ethane to, no? So, C double bond C H H. Okay. So, ito yung again, ito yung sigma bond. Any of the two naman, no? Basta may isa diyang sigma bond, then yung isa pang chemical bond, no? That is the p orbital to p orbital interaction naman, no? So, yun. What else do we know about those types of bonds, no? Okay. Balik ulit tayo sa sp3 orbital, no? So, sa sp3 orbital, ano meron, no? So, single bond lang yung meron from one atom to the other. So, if may single bond lang from two different atoms, that means the atoms are free to rotate, no? Ibig sabihin, malaya sila umikot, no? Kunwari, itong pencil ko na to. Pwede ko, kunwari ito, single bond to, no? Ayan, single bond tong kahaba. Nawala ako, no? O, balik ulit tayo, no? So, kunwari ito yung sigma bond, no? So, ito yung isang atom sa kaliwa. Ito yung kabilang atom sa kanan. So, sabi natin, kapag sigma bond, free to rotate yung atom. Pwede siya umikot-ikot, no? So, kunwari, i-grip ko yan na ganyan. Itong atom ko na to, pwede ko paikot-ikutin sa bond na yan, no? So, and it is free to rotate, no? Yan. Isa siyang consequence ng sigma bond, no? So, whenever you see sigma bonds, imagine that yung ating atoms doon, they can rotate about that bond, no? Pero what if may pi bond na? What if may p orbital to p orbital bond, no? Isipin nyo yan as dalawang lines, no? So, yan. Diba ito originally single bond yan? Ito. Ayan, so single bond yan, no? So, ito yung sigma bond, no? Pag nilagyan pa natin ng isa pang bond, no? Kunwari, ito na yung pi bond. So, pag dugtungin ko yung dalawang atom, pag inikot ko itong atom na to, medyo mahirap, no? Medyo nahihirapan nga ako hawakan yung dalawa, no? Medyo mahirap iikot itong atom na tong ginagalaw ko around this double bond because may restriction, no? Ano yung restriction niya? Ang nagpipigil para umikot yung atom about the double bond, no, is the existence of the extra bond in between the single bond, no? So, yun. May harang na kasing isa pa, no? So, may strain kung tawagin, no? May strain, so hindi siya makakaikot, no? So, may nagpipigil para umikot yung atom. No? At ang nagpipigil na yon, we call that the pi bond, no? So, whenever you have a pi bond, no, or you have a double bond, the molecule cannot rotate, no? Hindi na siya pwede umikot, no? Kasi, yun, may restriction na siya, no? May double bond na siya. Ito, last one, no? Last one ng parang wow, no? Ano kaya yung sinasabi mo sa ano? Kasi yan. Sige, so last one, no? So we have triple bonds naman, no? So, observe natin yung phenomena, no? Similar lang yung idea nito with the double bond and the single bond, no? So, how are triple bonds possible daw kaya, no? So, what happens is that, yun nga, di ba, kanina, ganito yung ginawa na natin, di ba? Yung isang electron ni carbon, pinapunta niya doon sa 2p. Sa sp3, lahat to gagamitin niya to form the sp3 degenerate orbitals, no? Capable of forming single bonds or sigma bonds, no? Sa sp2 naman, for double bonds, ang ginagawa ni carbon, hindi niya ginagamit itong buong apat, kundi yung tatlo lang. Itong tatlo lang, no? Itong isang pi bond kanina, ginamit natin to form the pi bond, no? Itong p orbital pala, ginamit natin to form the pi bond, no? While the other sp2 orbitals, no, they are used to form single bond or the atom-to-atom bond, no? The p orbital kanina, that is used to form the p orbital to p orbital bond, no? Pwede rin naman na ang gawin ni carbon daw is that after hybridizing all its orbitals is that hindi niya gagamitin yung apat, hindi niya rin gagamitin yung tatlo, kundi dalawa lang yung gagamitin niya, no? Choice niya yun, no? Bahala siya, electrons naman niya yan eh, no? So, instead of using all of those four or the three of them, it will only use the two of those electrons, no? One s orbital and one p orbital forming the sp orbital, no? Also, they are also degenerate, meaning same energy, no? So, pinagsasama niya itong dalawang orbital to form the sp orbital. Isa dyan galing kay s, yung isa dyan galing kay p, no? Hence the name sp orbital. So, ano gagawin niya dun sa hindi niya ginamit? So, yun, no? Parang katulad din nito, no? So, parang ganito lang din yung gagawin niya, no? So, this is the p orbital, di ba? Okay. So, if you have two p orbitals na hindi ginagamit, then you have two pi bonds, no? So, yan. So, ano nangyari? Sabi natin, di ba, may 2p orbitals na hindi ginamit, no? Ito, hindi to gagamitin to form direct bonds with atoms, no? Ito yung gagamitin to form direct bonds with atoms, also known as the sigma bond. Ito naman, ito yung gagamitin to form the pi bonds or the bonds between p orbital and p orbital, no? So, yan, ito. Tingnan natin yung tsura. This is the sp orbital, di ba? Okay? So, asan yung sp orbital, no? Ito, no? So, yan yung isa sa sp. Ito yung isa pa sa sp, no? So, yan. So, this bond, no? Itong sigma bond na isa, that is used to form the carbon to hydrogen bond, no? So, yan. Yan yung isa sa sp. So, asan yung isa pa sa sp? Yun naman yung ginamit to form the carbon to carbon bond, no? How about the 2p orbitals, no? Yung dalawang p orbitals na hindi ginamit. So, ito na siya, no? So, ito na yung una. Highlight natin. Ito yung unang p orbital. Tapos, ito yung pangalawang p orbital. Same goes for this one. No? So, yan. So, saan nyo ginagamit uli yung p orbitals? To form the pi bonds, no? So, the p orbital of one molecule will interact with the p orbital of the other molecule to form the pi bond, no? And since dalawa yung pi bond, no, that means may additional two bonds between carbon and carbon, no, other than the sigma bond here, no. So, ilang bonds meron na in between carbon na to and carbon na to? Bilangin natin. So, isang sigma bond, may isang pi bond dito. Ito yung isa sa p orbital. At may isa pang pi bond dito. Ito yung pangalawa sa p orbitals. No? Hence, the possibility to form the triple bonds na. No? So, asan dyan yung mga sigma bond? Yun yung single bond lang. Yung isang line lang. No? So, how about the pi bonds? No? Ito yun yung additional bonds. No? Ayan. Yan yung isa sa pi electrons, no? Ito pa yung isa sa pi electrons, no? So, ganun, no? Ang daming nangyari, no? Speechless ba kayo? Na-absorb nyo ba? Or okay lang? Or na-confuse? Sige, let me know lang your feedback. Clarify natin. Andiyan pa kayo, guys?
Yes po.
Ay, andiyan pa naman. So, summarize lang natin lahat na nangyari. Ang dami nangyayari, di ba? Pero don't worry, intro lang naman to eh. Kasi in the future, ganito lang gagawin natin. Identify the ganito ganyan. Di ba? Saya. Okay. So, summarize natin, no? So, sabi natin, no, in nature, we can find carbons forming different types of bonds, no? Different number of bonds with other atoms, no? It can form single bonds, double bonds, triple bonds. So, the question is, bakit may ganun, no? How come that it is able to form single bonds? How come it is able to form double bonds or triple bonds, no? So, the answer there is the hybridization, no? Or the hybridized atomic orbitals. No? Sabi natin kanina, ito yung original, no? But for carbon to be able to pair with other atoms, it needs to modify its orbitals, no? So, yung isang s orbital, lalagay niya sa p orbital. Then, what's next, no? After exciting one electron to the p orbital, may tatlong option siya. Gamitin niya lahat to form sp3 bonds, no? Or sp3 orbitals. Gamitin niya yung tatlo to form sp2 bonds or sp2 orbitals, or gamitin niya yung dalawa lang to form the sp bond or sp orbital. No? If the carbon chooses to form all the bonds, no, then it can come up with 4 sp3 orbitals. No? So, 4 na single bonds yung kaya niya gawin. No? Pag ginamit niya lahat ng kanyang electrons, no, to bond with other atoms. No? Ano itsura niyan? Ito, no? So, yan. Actually, ito yung itsura niya, no? Okay, so, yan. So, mapapansin natin, if carbon uses all the 4 hybridized electrons, it can form 4 atom-to-atom bonds, no? It can form 4 sigma bonds, no? Sigma, atom-to-atom, no? So, carbon can connect with hydrogen here directly through a single bond or sigma bond. Same is true for this part. Dito din sa taas, dito din sa gilid. Yun ay kung gusto nyo gamitin yung 4. No? What if ayaw nyo gamitin yung 4? Gusto nyo 3 lang. So, doon nabubuo yung double bonds. No? If carbon chooses to just use 3 bonds, no? Tapos yung isang bond hindi niya gagamitin, pwede niya gawin yun. may electron, may choice. Sabi niya, sige, bala ka. So, as it uses only 3 orbitals, no, ang kagawa siya dito ng sp2 orbitals. No? Tatlo yon, no? Kasi tatlong orbitals yan. Isang S, dalawang P. Hence the name sp2. No? So, tatlong bonds, ito yung gagamitin niya to form atom-to-atom bonds or the sigma bonds. No? Ano gagawin niya dito sa hindi niya ginamit? No? So, yung hindi niya ginamit, gagamitin niya yun na hindi niya gagamitin to form bonds with atoms directly, no? So hindi siya magpo-form ng bonds with atoms directly. Instead, no, magpo-form siya ng bond with the other 2p orbital, no? Okay. So ito yung tatlong sp2 orbital. So yung tatlong gray na yan, they will be used to form bonds with different atoms. This blue and green, no? Blue and green. Colorblind kagger. So, yan. Yung blue and red, no? This is the p orbital. This will be used to form hindi chemical bonds. This will be used to form bonds with the other p orbital, no? Such as here sa example natin, no? Okay. So, ito yung tatlong sp2 orbitals. Yun yung kulay gray. Yung tatlong sp2 orbitals, ginamit niya to form bonds with hydrogen sa likod, and carbon dito sa side niya. Yung p orbital na hindi niya ginamit, it will be used to form interactions, no? Atong interaction ng p orbital dito sa p orbital ng kabilang molecule, that will result in double bond formation, no? Last one, lastly, pwede rin naman dito sa apat na hybridized electrons niya, dalawa na lang gamitin niya kasi wala siyang, ayaw niya gamitin yung lahat eh. So, hindi gamitin is that pinagsasama niya itong dalawang orbitals na to form 2 sp orbitals, no? And the unused orbitals are dalawang 2p, no? Okay. So these sp orbitals, these are used to form atom-to-atom connections, no? So ilang sigma bond yung magagawa kapag sp? Dalawa. Okay? Atom-to-atom yung tinutukoy natin, no? So atom-to-atom, dalawang sigma bond, no? So para saan tong dalawang extra electron, no? So those extra electrons can be used, no, to interact with the p orbitals din ng kabilang molecule, no? Atom pala, ng kabilang atom, no? So yun. So ito yung dalawang sp orbital. Yan, isa and dalawa. Yan yung dalawang sigma bond, no? Yung kulay gray. Yung nilalaser natin. Then, nasan yung unused p orbitals? Itong blue and red, no? So ito yung una. This is used to form bonds with this one sa kabilang atom. Ito naman, this is used to form this pi bond with the other atom, no? Hence the formation of triple bonds. Isang bond yan, isang bond yan, isang bond yan. Hence the formation of triple bonds, no? Okay, so summarize na lang natin, no? Ilang beses ba ako kailangan mag-summarize? Para ma-emphasize lang natin. So, emphasize natin dito sa gilid, no? Pag sp3, ilang sigma bonds ang magagawa? Anyone. Pag sp3 orbitals, no? Ilang sigma bond ang kaya gawin? Hello guys. Okay pa kayo dyan? Pag sp3, ilang sigma bond yung kaya gawin? Yun yung apat kanina, no? 4 sigma bond, no? or 4 single bond, no? Kaya nyo mag-form na 4 na bonds with different atoms, no? Okay, that is for sp3 hybridized carbon. Pag sp2 naman, ilang sigma bond kaya niya gawin? 3. Asan yung isa? Magiging pi bond, no? So, makikita natin dito na may 3 single bond and may teka lang, wait lang, kamali ng sulat. Siguro na-overwhelm na kayo, no? Pag nakita nyo yung examples nito, sabihin nyo, ay, ganun lang pala. Madali lang pala yung examples, yung application, no? Yung kwento kasi medyo complicated, no? Pero pag nakita nyo yung usage niya, yung usage lang ng idea, madali lang, no? Bibilangin mo lang yung mga bonds, no? Okay. So, ayun, no? So, for sp2, 3 sigma bonds will be formed and may isang pi bond, no? So, dito may existence ng double bonds, no? Yung makikita kang double bond, no? So, every time you see a carbon that contains double bond or any atom that contains double bond, that means it is sp2 hybridized, no? Okay. Pag sp hybridized naman, you have 2 sigma bond and 2 pi bond, no? So that can be seen as triple bond, no? So kapag may tatlong bond, automatic sp or sp orbital yan, no? So yan. Ayan. So yan lang naman yung medyo complicated story behind this, no? But again, no, sabi ko nga, yung story behind all those types of orbitals lang naman yung complicated, no? Ang madali ay yung application, no? So let's apply that idea. Identify the hybridization state of each carbon in the following compounds, no? Piling ko kayo sabay na kayo dito, no? Okay. So each carbon, no? So I will identify carbon 1, carbon 2, carbon 3, 4, 5, 6, 7. Looking at carbon 1, judge natin si carbon 1. Do you see any double bonds or triple bonds na nakadugtong kay carbon 1? Yes or no? Ay, meron ba or wala? Meron ba double bond? Meron triple bond? Wala naman, di ba? So, meaning nun, carbon 1 is sp3 hybridized. Yan lang. Di ba? Ang complicated ng story behind, pero yan lang yung gagamitin natin. Di ba? Ang saya ng life. So, yun na naman sabi, identify the hybridization of each carbon. Carbon 1 is sp3 hybridized because it only contains single bond, no? 4 single bonds. No? Single bond, single bond, single bond, single bond. Carbon 2. O kayo naman, carbon 2. Tignan nyo yung mga bonds around carbon.
sp3 hybridized din po.
Yun. Di ba? Alam nyo, to be honest, no? Nung kinakwento din sa amin nung college itong hybridization ng orbitals, parang kami na pa, huh? Parang single lang talaga yung unang reaction namin. Parang, ano yan? So, ano yan? Shape na yan, no? Pero yun lang pala yung story behind the double bonds and the triple bonds. So, yun. So, una lang siya complicated, but yun. For the rest, easy na yan, no? Magiging parang automatic na siya sa utak nyo. No? So, yun. So, for carbon 2, the carbon is sp3 hybridized because as you can see, walang double bond kay carbon. Single bond yan, single bond yan, single bond, single bond. How about carbon 3?
sp2?
sp2.
Yun, sp2, o diba? So, sp2 hybridized. Brain ko naman yung term na hybridized. Sayang yung space. Ay, sige na, burahin ko na. Wait lang. At tayo mag-zoom. Ayan. So, carbon 1, sp3. Carbon 2, sp3. Carbon 3 is sp2.
sp2.
Kasi, as you can see, may double bond, no? That is attached to this carbon, no? So, yan. Ito isang sigma bond. Sigma bond. May isang sigma bond. Yung isa sa double bond, yun yung pi bond. So, hindi to sigma bond, ha? Isa lang dyan yung sigma bond. Ito lang, or itong nasa taas, no? The other is the pi bond, no? Okay, so every time you see double bond, sp2 hybridized carbon yun, no? Carbon 4.
sp3.
Yun, sp2, di ba? Yan, so sp2 yan kasi may single bond, tapos may double bond dito. Yun, no? How about carbon 5?
3 po.
sp3.
sp3.
sp3, no? Because you can see, puro single bond lang yan, no? Ayan. Diba? Ang haba ng kwento natin kanina. Dali lang naman pala. Carbon 6.
sp.
sp.
Ayun, sp. Nice, no? Kasi pag may triple bond, automatic sp. Asan yung single bonds, no? Ito yung isang sp, sp bond. Ito yung isa pa. Tapos yung dalawa dito, pi bond, no? So, ganun. Ito, isang sigma bond. Yung isa, pi bond. Pag triple bond naman, isa lang din yung sigma bond.
Sigma bond, dalawang pi bond.
Dalawang pi bond. Ayun, no? Diba? Saya-saya ng type. Carbon 7.
Same lang po.
Same lang.
sp.
Ayun, no? So, yan. So, very good, no? So, yung mga kwento ko kanina, yung application niya, yan lang, no? Diba? No, paisip ka, dami nyo sinabi, sir, yan ang paling gagawin, no? Ganun talaga, no? So, every time you see double bonds, sp2. Every time you see triple bonds, sp. Pag single bond lang, edi sp3. So, yun. Any questions?
Sir, kapag ba nagka-count po ng ilan na carbon, laging left to right?
Yung?
Pag po nagka-count po ng carbon, kapag hinahanap po yung hybridization state, laging left to right po ba yung pag-count ng carbon?
Ay, hindi naman. Yung numbering ko naman is ano lang, arbitrary.
So depende din po sa label nyo?
Pwede ka dito mag-start na.
Okay po.
Di left to right ko na lang para pataas tayo.
Okay.
So, ganun na. So, yung counting ng carbon, malalaman natin yan when we started discussing alkanes, no? Alkanes, alkynes, no? So, yan. In the future, malalaman nyo yung proper numbering ng carbons, no? And basta the idea is, yun nga, pag single bonds, sp3. Pag double bonds, sp2. Pag triple bonds, sp lang. Ayan, no? Kayang-kaya nyo na to, no? Determine the hybridization state of each carbon in the following compounds. So may activity na tayo, no? Ako sa A, tapos kayo na sa B, C, D, E, no? So yung carbon lang, ha? Carbon lang gusto natin tignan kasi siya yung inaaral natin, eh. So for letter A, for this carbon, this is, makikita ko, puro single bond lang naman yung nakakonekto sa kanya. That means may 4 na sigma bonds na nakakonect sa kanya. So kapag may 4 na sigma bonds, sp3. No? This carbon, may nakikita akong double bond with oxygen. No? So most likely, may 3 sigma bond yan. Ito yung unang sigma bond, carbon to carbon. Ito yung isa pang sigma bond, carbon to carbon. Yung isang sigma bond is the carbon to oxygen. Ano tong isang bond na to? This is the pi bond, no? The p orbital of carbon interacts with the p orbital of oxygen, forming the double bond, no? So, since may double bond yan, sp2. Dito naman ako. So, may nakita na naman akong double bond. So, automatic, sp2 na yan, no? Same goes for this carbon, sp2. Diba? Easy. Ayun. O, B. Sino gusto sa inyong mag-recite, no? Na-numberan ko yung carbon, identify ko, lalagyan ko ng arrow yung carbon, tapos sabihin nyo kung ano yung kanyang hybridization. Sino mauna? Bato topic kayo ni Cart and Rica. Sabihin nyo na, no? Sige, si Nicard na. Okay, so si Nicard, no? Sige, start tayo. Okay. That carbon,
sp3 po.
sp3. This carbon,
sp.
yun. This carbon,
Same lang po, sp.
sp. This carbon,
sp3.
this carbon,
sp3.
ayun, bilis, no? Okay, so, ganun lang, ha?
Apa.
Mamaya screenshot nyo yung mga sunulat nating sagot. Okay, letter C. Si Rika naman. This carbon,
sp3,
yun. This carbon,
sp2,
yun. Ito,
sp2 din po,
ito.
sp3,
Yun, galing naman pala, eh. Letter D, si Nicart ulit, no? Ito,
sp2 po.
sp2. Ito,
sp.
sp yan, no? Okay. So, hindi siya, no? sp nga ba yan? sp lang yan, no? Kasi, yun, ginamit
Dalawa
lang,
pong-
no? Ito yung isang pi band, di ba? Ito yung isang p
Apo.
orbital. Ito yung isa pang p orbital. Kasi ito lang yung sigma band. sp yan, ito. sp lang din. Ikaw pala yung magsasagot. Itong isa, sp.
sp2 po.
Yun. Ganun, no? Mamadali na. Gusto na kumain, eh, no? Ito. Pasiri ka.
sp2,
And ito,
sp,
sp na lang yan pag ganyan, no? Kapag puro double bonds na sa paligid ni carbon, may double bond sa kaliwa, may double bond sa kanan, sp na lang din yun, no? So, yun. Okay na tayo doon, no? Ay, salamat sa Diyos. Screenshot nyo na lang yan, answers natin. Screenshot. Ayan, screenshot. Nasa ito pa, screenshot. Tapos, onting slides na lang. Ay, salamat sa Diyos. Ay, ang dami pa. Ano ba yan? Sige. So, anyway. So, punta na tayo sa concept naman ng bond strength and bond length, no? So, sino yung bond na matibay? Sino yung bond na hindi? Sino yung bond na maigsi? Sino yung bond na mahaba, no? Okay. So, punta na lang tayo dito sa summary sa dulo ng slide, no? So, sabi dito, the bond lengths, sp3 bond lengths are the longest, followed by sp2 and sp, no? So, yun. Tingin na lang tayo dito, no? So, this is sp3, this is sp2, this is sp, no? So, looking at the bond length, no? Ano mapapansin natin? sp3 bonds are the longest. So, mahaba yan kaysa sa sp2. And mas mahaba to compared to sp, no? So, yung ano lang naman, yung trend lang gusto natin makuha dito. So, for bond length, increasing trend tayo from sp to sp3. So, ibig sabihin, humahaba yung bond length, no, between atoms if they are sp3 in hybridization, no? So, mas mahaba yung clearance nila from one atom to another. Pag sp2, di masyado. Pag sp, siya yung pinakamaigsi, no? How about bond energies, no? So, for bond energies naman, ano mapapansin natin? For single bond, ito yung energy, 368 kilojoules per mole. Pag double bond, 600 plus, and kapag triple bond, 800, no? So, ano yung pwede natin makuhang information dito, no? So, ang intuition na pwede natin is, makuha natin dito is that the more bonds you have to break, the more energy you have to input, no? Ibig sabihin, mas matibay kasi yung bond kapag mas maraming bonds. Mas matibay yung bond kapag mas maraming bond, no? Kasi, in order for you to cut that, no? Pag sp3, isang bond lang puputulin mo, hindi madali lang putulin, no? With just 300 kilojoules of energy, I can cut this. Pero, if may double bond ako, I have to apply double the energy para maputol yan, no? So, I have to apply 2 times of energy kasi may dalawang bond, no? Parang na-double yung kanyang factor. So, for triple bonds naman, almost triple yung factor, no? Kasi marami akong puputulin, no? So, for bond length, no? Shortest, si SP, longest, si SP3. For bond strength, strongest, si SP, ang weakest ay si SP3, no? So, ito yung weak, madali lang siya putulin. Ito yung strong, no? Take note nyo na lang yung trend, no? Sige. Okay. So, habang dumadami yung double bonds, or habang dumadami yung pi bonds, mas lalong umiigsi, pero mas lalong lumalakas yung bond, no? Because of the added, interactions, no? So, yan. Rank the indicated bonds in terms of increasing bond length. Sige. I-rank down natin yan in terms of increasing bond length. No? So, sige. Paano natin gagawin yun? Increasing bond length. Okay. We judge the carbon muna, no? Or we judge the bond, no? Based on the hybridization of the carbons around it, no? So, since ito ay single bond lang, so this is sp3, no? Okay? So, since ito ay double bond, ito ay sp2, and since ito ay triple bond, sp lang yan, no? So, if I'm going to rank bond 1, bond 2, and bond 3, sino yung pinaka mahaba? Longest to shortest. Shortest. So, sino yung longest?
SP3.
Yung carbon bond 1, no? Followed by
2.
carbon double bond, no? Yung ikalawang binilugan natin. And yung pinakamaigsi is yung ikatlo, syempre, yung triple bond, no? So, ganun lang how to judge the length of the bonds, no? You just identify the hybridization of the carbons around it, no? Or the shortest way is tignan mo kung ilang bonds meron, no? Strongest to weakest naman tayo. Sino yung strongest sa tatlong bonds? 1, 2, 3. Si?
3 po.
Si 3 ang strongest because sp3 yan eh. Strongest yan, followed by?
Carbon 2.
Yung bond 2. And lastly, yung bond. So, yun lang yung idea, no? So, sige, screenshot nyo yan. Ayan. Dilim na eh. Okay. So, ganun lang. Ganun lang, di ba? Matagal lang talaga yung idea sa una, pero ngayon, medyo mabilis na tayo, no? So, next one, favorite nyo, drawing, molecular geometry, no? Okay. So, when I say molecular geometry, ito yung shape ng molecules, no? On how they interact, no? And the main factor for determining the shape of the molecule is the theory of valence shell electron pair repulsion, or the VSEPR. No? VSEPR basa ko dyan eh. Yung iba naman, VSEPR, no? Basa ko VSEPR, no? So, ano yung pwede natin makuha idea or ano ba yung main principle of the Vesper, no? So according to Vesper, or the valence shell electron pair repulsion theory, is that yung ating electrons, di ba negative charge sila, no? Okay, so kunwari, I have these two electrons. Pag pinagtabi ko yan, what will happen to them, no? Since they have the same charge, they will repel each other, no? So, parang magnet, no? Sa magnet, pag pinagdikit mo yung parehas na side, lumalayo sila isa-isa't isa, di ba? In atoms, the same is true, no? Kapag yung bonds, which is full of electrons, kapag nagdikit yung bonds, no, magkakaroon ng repulsion, no? So, yun, in order for them not to have repulsion, ano yung gagawin nila? They will orient themselves into 3D space, no? In such way na may shapes tayong mabubuo, no? So, may ayun, naputol na naman. May trigonal bipyramidal, may octahedral, di ba? Pero for the purpose of organic chem, hanggang tetrahedral lang tayo, no? Okay, so bigyan natin ng shortcut, no? Para mas mabilis yung pag-aaral natin. So, for you to determine, ito shortcut to ha. So, for you to determine the molecular geometry, you have to identify first the steric number. So when the steric number is asked, no, all you have to do is to count the number of sigma bonds, no? Count mo kung ilan yung mga bonds, no? Ilang bonds siya with atoms, no? So yung mga double bonds, you count them as one lang, no? And yung triple bonds, you count them as one as well, no? Okay. So yun, so you count the number of single bonds around, sigma bonds around the atom, and you count the lone pair, no? And then ipag-add mo yung dalawang number, no? Okay, so each steric number corresponds to a different shape, no? Which I will show you mamaya, no? Okay, so for this carbon, no? This is methane, yung CH4. So, ito yung example natin kanina sa hybridization, no? So, alam natin that its shape is tetrahedral, di ba? Okay, so kunin natin yung steric number. So, to count the steric number, bilangin mo yung sigma bond. Isa, dalawa, tatlo, apat. Lone pairs, yung dalawang tuldok. Wala naman dalawang tuldok doon, so 0. So, you just add the 2 to get the steric number 4, no? Next one, we have ammonia, NH3. Number of sigma bonds or number of single bonds, tatlo, isa, dalawa, tatlo. And the number of lone pair is isa lang. Okay, so 3 plus 1 is 4. And for water, H2O, we have 2 sigma bonds, oxygen and hydrogen bonds. And we have 2 lone pairs around the oxygen, no? So, yeah. So, the steric number is 4, no? So, yeah. So, we can observe that they have the same steric number. Hence, they should have the same geometry, no? Mamaya makikita natin yan. So, anyway, we can also use the idea of the hybridization to identify the steric number, no? And vice versa, no? So, if we have a steric number of 4, take note nyo na to, no? So, if you have steric number of 4, sp3 hybridized yung atom sa gitna, no? So, every time na it assumes sp3 hybridization, so its geometry is most likely tetrahedral, no? Pag ang steric number ay 3, then the central atom, no, is sp2 hybridized, no? When it is sp2 hybridized, it follows the geometry of trigonal planar, no? Para siyang flat na triangle. Di ba yung flat na triangle may tatlong edges, no? So in each edges, andun yung tatlong atom na nakadugtong doon kay central atom, no? Then last one, if the steric number is 2, ay dalawang nakadugtong sa kanya, then it is sp, no? When we have an sp hybridized atom, then the shape is linear. Straight line lang siya. Okay. Okay, so punta muna tayo sa steric number 4, no? So let's focus on the tetrahedral shape, no? Okay, so sabi natin dito, if you have sp3 hybridized atom, it will follow the tetrahedral electron group, no? Okay. Wherein the bond angles between one bond to another, no, is around 105 to 110 degrees Celsius, no? Okay. So if you have no lone pair, ito more on memorization na lang to, no? If you have no lone pair, the band angles, no, angles, no. The band angles is 109.5, no. Okay. So it okay. So yun, it follows the shape of a tetrahedron if it is sp3 hybridized, no. Paano naman kapag may lone pair, no? Sabi natin kanina, lone pairs, dati pa pala, no? Lone pairs, andun yung electrons, no? So we actually have two electrons in that position, no? So what happens is that yung electrons dito, they push, tinutulak nila yung ibang bonds, no? Pababa, no? Pinipit-pit nila pababa kasi malaki yung space na gusto nila, no? Malaki yung space of interactions nila. So what happens yung mga bonds, no? Instead to repel, no, is nag-a-adjust na lang sila para sa lone pair. So nangyari, lumalayo sila from the lone pair, no, or dumidikit sila from one another. Hence, you can see, pag may one lone pair, the band angle, no, the band angles decrease, no, from 109 to 107. More on memorization na lang to, no. So yun. Pero kapag may dalawang lone pair ka, no, sabi nga natin, itong lone pairs na to, they are electron rich, no? And as a result, they repel bonds, no? Kapag may dalawa ng lone pair, mas marami na silang nire-repel ngayon, no? Hence, what happens to the bond is that mas lalo silang nasisiksik, no? Mas lalo silang napagdidikit, no? That's why we have a decrease of bond angle, no? From 109.5 to 107 to 105 degrees, no? So, yun. Screenshot nyo na lang, no? Ano, may copy naman pala kayo ng ano. May copy kayo ng PowerPoint, no? Okay. Ayan, no? So, sige. Ano to? No? So, ito yung mga common shape of our molecules that can be predicted with the Blesper theory, no? Ito yung mga shape ng molecules depending on the steric number, no? So yun nga, sabi ko nga sa inyo kanina, just remember the formula for steric number, count the bonds, the sigma bonds, and count the lone pairs, no? So if you have 4 sigma bonds, no lone pairs, it follows the shape of a tetrahedron. Ito yung shape ng tetrahedron, no? Pero, if you have a steric number of 4, tetrahedral siya, di ba? Pero, yung isa doon sa apat na yon ay lone pair, then it follows this geometry, the trigonal pyramidal, no? So, asan yung trigonal pyramidal dyan sa ammonia? Ito yung triangle. So, yun yung base ng triangle. Para siyang pyramid. Tapos, andito yung, ano, yung pusa ng Egypt, no? So, yan. So, yun yung idea, no? So, originally, tetrahedral siya. Pero, tanggalin mo yung nasa taas, you have your trigonal planar. So, kailan natatanggal yung nasa taas, no? If may isa kang lone pair. So, all of this is memorization na lang, no? So, you can remember this at home. Ay, nasa bahay mo pala kayo. Okay. So, Also, if you have the steric number of 4, no? Tapos, what if kunwari, dalawa yung electrons niya, electron pairs, no? Then the shape will be bent, no? So, yan, no? Naging bent na yan, no? So, hindi natin tinitake into account yung shape ng para sa electrons, no? We are more concerned on the chemical bonds, no? So, bend yung shape ng bond, no? If you have a steric number of 4, but 2 electron pairs, no? So, yan. If you have a bonding pair naman na tatlo daw, dito punta tayo. So, looking at this boron tetrafluoride, BF3, no? So, mapapansin natin that there are 3 sigma bonds around it, no? So, pag may 3 sigma bonds, that correspond to a steric number of 3, no? Steric number. Sigma, tatlo. Lone pair, wala, no? So, add natin yung dalawa, 3, no? So, if the steric number is 3, this corresponds to an sp3, ay hindi sp3, sp2 pala. That corresponds to an sp2 hybridized orbital, no? So that means the shape of the central atom is trigonal planar. So you have to remember trigonal planar ang shape pag sp2. Ano yung itsura ng trigonal planar, no? Para lang siyang triangle na papel, no? So yan, flat yan. Sa edges ng triangle, andun yung atoms, no? So, ganun. So that means, no, na yun, trigonal planar siya. Wala na akong ibang masabi. Paano naman kapag steric number is 2, no? So, pag steric number is 2, we only have 2 sigma bonds, no? Then the shape is linear, no? So, yun. Also, if the steric number is 2, remember that kapag steric number is 2, we have an sp hybridized orbital. The shape is linear. No? So, more on memorization. No? Okay. So, let's summarize everything. Ito yung pinaka-summary. Ito na yung guys. No? If you have steric number of 4, it is sp3 hybridized. The general shape is tetrahedral. Okay? Then, kapag walang lone pair, edi tetrahedral yon. Pag may isang lone pair, you just remove one of the vertices of this tetrahedron. You get your trigonal pyramidal. Okay? If you have 2 lone pairs, then magiging bent yon. No? If you have a steric number of 3, sp2 hybridized yung central atom, that corresponds to a shape of trigonal planar. Pag wala kang lone pair, trigonal planar lang yan. No? But if you have 1 lone pair, tanggalin mo yung isa dyan, ano yung itsura? Bent. No? Kaya napunta ulit dito sa bent. If the steric number is 2, you have an sp hybridized atom. The shape is linear. So, naman ako. Ayun. So, nawala na naman ako. So, yun. Screenshot nyo siya and i-save nyo siya, no? So, remember all the shapes, no? Pasalamat na lang tayo kay OrgChem, hindi tayo umaabot ng octahedral, trigonal bipyramidal, no? So, yun. Salamat, OrgChem. Okay. So, with that, no? With all those stuff in mind, no? Tingin tayo dito. So, we will predict the geometry, no? So, magsasagot lang tayo ng ibang article items dito. Then the rest will be for you to answer, which you will comment also in our discussions page, no? Yung answers bibigay ko sa Monday. So, holiday naman yun. We have more time to study and rest, no? Pero syempre, rest muna, no? Okay, so let's use our ideas about steric number and the Vesper theory in predicting the geometry of the following molecules, no? Or the following structures. Letter A, we have BH4, no? Boron with 4 hydrogens around it. Itong negative na to, itong positive na to, yun ay formal charges lang. Okay, remember yung formal charge last time. Okay, so yan, nilagay lang siya dyan. Letter A, looking at this molecule, what is the steric number?
4 po.
4, because it contains 4 single bonds. 1, 2, 3, 4. So if you have a steric number of 4 but no lone pairs, the shape is
Tetrahedral.
tetrahedral. Tetra H na lang. So yan, ganun lang, no? Basta kabisado mo, okay tayo doon, no? Ay, ano ba yan? Tetrahedral. Oh, letter B. What is the hybridization of boron in BF3? Ay, ito yung example kanina eh. Sige. Steric number of BF4, ay BF3.
3.
3 pairs, 0 lone.
Yeah, so we have 3 sigma bonds, so no lone pairs. The steric number is 3. So steric number of 3 corresponds to a shape of
Trigonal planar.
yun. So trigonal planar yung shape. Trigonal planar. Yan yung shape niya. How about letter C?
4.
Steric number
4.
Same lang po.
4. So, no lone pair, di ba? So, what is the shape?
Tetrahedral din po.
Tetrahedral. Tetra. Letter D, steric number.
4.
What is the shape?
Tetrahedral.
Ayan. So, ganun lang, no? As long as you know the steric number and the general shape, no? You can answer the following structures, no? Kaya naman pala sagutan to lahat. Number 1.28. Compare the structures of a carbocation and a carbanion. Carbocation, that means the carbon is positive in charge. No? Formal charge is positive. The carbanion is negative in charge because of the excess. This I Ayan, nagbabalik na naman tayo. So, in one of these ions, the central carbon atom is trigonal planar, while the other is trigonal pyramidal. Assign the correct geometry for each ion. Which of the which of the two is trigonal pyramidal? So, iba na ako nakatingin.
Carbanion.
Carbanion si trigonal pyramidal. One term kasi, no, for tetrahedral is trigonal pyramidal. So, yun. So, carbanion is trigonal pyramidal, no? Kasi the original shape is tetrahedral. Pero because of the one lone pair, mare-reduce siya into trigonal pyramidal, no? So, yun. This is trigonal pyramidal. So, that means carbocation is trigonal planar, no?
Planar.
Yun. Kasi carbocation is sp3 hybridized, no lone pairs. So, it assumes the shape of trigonal planar. However, ito naman si carbanion, the steric number is 4. May isang lone pair. So, from tetrahedral, it will be reduced to trigonal pyramidal. 129. 1.29, ammonia will react to strong acid, blah, blah, blah. Using Vesper theory, determine whether you expect a change in bond angles when ammonia is converted into an ammonium ion. Explain. Is there an observable change in the bond angles between ammonia and ammonium ion? They have the same steric number, which is 4. Tatlong single bond, isang lone pair. 4 na single bond, no lone pair. So still the same steric number. But do you think there will be a change in bond angles between the two molecules? Kakaroon kaya ng pagbabago sa shape ay sa angles ng bond?
Yes po.
Bakit may change? Because
Although they have same steric number, there is one lone pair for ammonia.
okay. And what does the lone pair do to other bonds? Anong ginagawa ng lone pair sa ibang bonds? Pinupush niya, di ba? So, according to our Vesper theory kanina, eto na. Ay, binura ko pala. So, anyway. So, the idea is that if you have electron pairs here, they push the chemical bonds, no, away from them, no. So, as a result, mas umiliit yung bond angle between the atoms, no. However, if itong lone pair naging chemical bond, babalik siya dito sa original angles na 109.5, no. So, yan. So, natapos natin yung mga activity natin, no. Okay. Lapit na tayo natapos. Ay. Okay, so, kala ko maaga tayo matatapos. Pero okay lang. Maganda na yung ano. Tapusin na rin natin lahat, no. Dipole moments, no. Okay, so dipole moments and polarity. So this idea, no, has something to do with our previously discussed topic na electronegativity and the partial charges, no. So remember, if your atom is more electronegative than the other atom, no, na nakabond sa kanya, example, we have this molecule, no. So chlorine is more electronegative than carbon, no? Based on the periodic trend, no? So, mas electronegative yung group 7, yung family ng halides, as compared to group 6, the family of carbon, no? So, group 4 pala, sorry. So, yung group 4, less electronegative than group 7. So, that means the electrons of carbon will go towards Cl. And that produces the partial negative charge for chlorine and the partial positive charge for carbon. No? So the movement of electrons from one side of the molecule to the other side is also called the induction effect. No? Induction meaning the electrons are moving along the orbitals or along the chemical bonds. No? So, yan. So, dumadalo yung electrons towards Cl. And as the electrons proceed towards Cl, nagiging negative yung side ni Cl, nagiging positive yung side ni carbon. No? That's the idea we presented last time, di ba? And since may dalawa tayong charges, we have the negative and the positive charge. Then we have the dipole moment. No? So what is a dipole moment? So dipole, dalawang poles, no? Dalawang charges, no? Ano yung dalawang poles natin? Dalawang charge, no? The negative pole, the negative charge, and the positive pole, the positive charge, no? So we represent the dipole moment using this arrow, no? Okay, so ano sinisimbolize ng arrow na ganito, no? Ano meaning ng arrow na ganyan? Ayusin natin. Okay. So, ano meaning niyan, no? So, dalawang parts meron tayo dyan, no? So, mapapansin nyo, parang that is a positive sign, di ba? Para siyang cross. Pointing to somewhere, no? So, ano lang meaning nun is that the side that is partially positive is signified by this cross. Nandiyan yung partial positive, no? Then yung arrow, kung saan papunta yung electron, nakatutok yun sa partial negative side, no? So, yun. So, yun ha. Ito yung dipole arrow. This is the dipole arrow. It has two parts. The positive end, no, going to the direction ng kung nasaan man yung partial negative end, no. And yun. So, mapapansin natin, pataas yung movement, no. So, yun. So, that is the dipole moment, no. Meaning the dipole direction or the movement of electrons, no, within a molecule. Okay. So, for molecules with multiple bonds, the dipole moment is the sum of all the directions, no. So, and if we have lots of different, we have lots of different atoms bonded to our central atom na may dipole moment, no? So, their direction will sum up, no? Pag-a-add lang natin yung direction. For example, we have here C bonded with Cl and dalawang H, no? Yung CH bond, hindi naman yung polar, di ba? But the CCl bond, this is polar. Cl is partially negative. So, dun pupunta yung electrons ni carbon. Electrons ni carbon pupunta kay chlorine. Hence this dipole arrow going to this chlorine and going to the other chlorine now. If we add the two directions, pag pinag-add natin yung dalawang direction na yan sa physics, the vector sum is this one na. Etong, ayan. So pag pinag-add natin yung vertical and yung pababa, no, at a certain angle, it corresponds to a direction that is bisecting the angle, no? So, yan. So, ito yung pataas, ito yung pababa, ito yung vector sum, no? So, anyway, meaning lang nun is that the direction of the molecules, electron, no? The movement of the electrons, they point to a direction lang, no? So, yan. What else, no? Ayun, dito rin kay nitrogen and hydrogen, no? The bond is actually partial in charge, no? So the electronegativity of nitrogen is greater than that of the hydrogen. You can observe polar bonds here, no? So yung electrons ni hydrogen, they will go to the more electronegative nitrogen, and may tatlo yan sa baba, no? Imagine nyo ito yung nitrogen, itong pink na to. So, imagine mo may tatlong tumutusok sa kanya pataas. Ay, hindi pang nasa mic lang pala napunta. Okay. So, imagine nyo yung nitrogen, ito yun. Tapos may tatlong electrons na pa-push pataas. So, what is the net direction? Pataas lang din, no? So, yan. So, yung mga tatlo yan, pataas yan, papunta kay nitrogen, no? Hence, the net dipole moment is upwards, no? For water, ganun din, no? Take note of the geometry, ha? Okay. So, yan, for water, with the correct geometry, there is a movement of electron from hydrogen to oxygen because oxygen is more electronegative than hydrogen, di ba? So, electrons are moving from here to here and from here to here. So, pag pinag-add nyo yung dalawang direction, no, na going upwards, you will have a net moment of pataas, no? So, ano naman yung kinalaman yan with polarity, no? Okay. So, dipole moment and polarity are similar to each other, no? That means if you have a dipole moment, may direction yung electrons. That also means that your molecule is polar, no? Polar yung molecule mo kapag may dipole moment, no? So, let's consider chloromethane, no? So, the direction of electron is isa lang, pataas, no? Okay? So, what happens is that yung side ni chlorine, that becomes a partial negative side, and yung side sa baba, no, yung aalisan ng electrons, siya magiging partial positive, no? So what happens is that we are creating two poles, di ba? They're the dipole, no? So kapag may poles tayo, may positive and negative charge, no? Then we have the polarity, no? Okay. That's why water is also polar. Bakit polar yung water? Because may positive side siya and may negative side, no? This is the positive side of water. This is the negative side. Hence, water is polar, di ba? So, yun yung reason bakit may mga ganun. So anyway, so these are the common organic solvents and their polarity, no? So let's take a look at acetone, no? We're not going to check them all, no? So acetone na lang and ammonia. Acetone na lang. Yung ammonia na bigay na natin sa previous slide. So for acetone, it is polar, no? Okay, so paano siya naging polar? So looking at the bonds of the atoms, the polar bond is the carbon-oxygen bond, di ba? Yung CH bond non-polar yan, yung CC bond non-polar, but the CO bond is polar. So oxygen is more electronegative, so partial negative sa side na yun, partial positive dito sa lower part, no? So as you can see, may two different charges, no? So as long as you have two different charges, ayan, so you have the positive side and the negative side, then you have a polar molecule. No? Ayun. No? Nakahingal pala magsalita. Okay, so sagot lang tayo ng ibang items dito. No? So, kasi in the rest, sagutan nyo na lang sa bahay. No? Ay, nasa bahay nga pala kayo. Ano ba yan? Sige. Identify whether each of the following compounds exhibit molecular dipole moment. So, for the compounds, let's do indicate the direction. Sige, so let's do this, no? Letter A. By the way, always take note of their geometry. Yan yung reason ba't diniscuss natin siya earlier. So let's try CHCl3, diba? We usually draw CHCl3 as Cl, 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 and H, diba? Yan yun, diba? Okay. But that is not the correct structure. Hindi yan yung correct shape niya. Kasi remember, what is the steric number for this molecule? The steric number is
4.
4. So what should be the shape? Ano dapat yung shape niya?
Tetrahedral.
So tetrahedral, no? So instead of drawing it that way, we're going to draw it according to the geometry, no? So carbon nandyan, may tatlo sa baba, and meron sa isa, no? Yung next chapter natin, yun, magdo-drawing talaga tayo. Puro drawing lang. Okay. So tignan natin kung polar siya, no? Or may dipole moment, no? CH bond is non-polar. So, okay tayo doon. Wala tayong issue dyan. But the CCl bond is polar. Sino yung negative, partial negative side?
Cl.
Yung Cl. Kasi Cl is more electronegative than carbon. So, may papunta dito sa baba. Yung dipole moment niya. Meron din dito. Pababa din yan. Tapos meron din doon pababa. So, overall, may tatlong pababang directions, di ba? So, the net dipole moment is pababa, no? So, pababa yung net dipole moment, no? So, pababa, no? So, since we have a net dipole moment, no? May net direction. That means the molecule is polar, no? So, ganun lang, no? So, sige, screenshot nyo yan for your reference, no? Okay, yung aso yun, yung bundok niya. So, anyway, so screenshot nyo yan. Okay, so I will proceed answering letter B. CH3. Oh, CH3, no? By the way, this is the structural formula, no? And this is, next meeting pa natin mag-discuss yung mga ganun, no? We have the condensed formula, structural formula, empirical formulas, no? So on and so forth. But again, ano yung pwede natin makuha with the structural formula? It tells us kung ano yung position ng atoms, no? sa isang molecule. For example, CH3OCH3, that tells us that the oxygen is in between the two carbons. Kasi di ba last time yung ginawa natin, condensed formula yun eh. Yung magkakasama na lahat ng carbon, lahat ng H, then oxygen, tapos bahala ka mag-interpret na. This time, hindi, no? So this time, alam natin that the oxygen is sandwiched between two CH3 parts, no? May dalawang CH3 sa paligid ni oxygen, no? So, ito yung si oxygen. Remember, may dalawang lone pair siya. Important yan because we just discussed molecular geometry, di ba? Okay. So, do not forget the lone pairs this time. Then we have carbon here. Yan yung CH3 sa right side. Ito yung CH3 sa right side, CH3. And sa left side, ganun din. No, so yan. So this is our typical Lewis structure for CH3 or CH3 or the dimethyl ether. No? But again, for us to predict to predict if that is a polar molecule or not, we have to assign the correct geometry first, no? That means we have to take into account the steric number. So, this carbon, ano yung steric number niya?
4.
So, that is in the shape of a tetrahedron. How about this oxygen? So, that oxygen,
2 electron pairs, 2 lone pairs.
so ano siya, no? Steric number of 4, but because of the 2 electrons, its shape will be
Bent.
bent, no? Magiging bent na yung shape niya. Hindi na siya tetrahedron, no? Itong carbon na yan, same lang naman, so tetrahedron lang din yan. So, what I'm going to do now is I am going to draw this molecule with the correct geometry, no? So, for now, allow me to draw this, no? Sir, paano naman kami sa susunod? Ayan, no? May drawing na naman yung mga papasagot ko sa inyo sa bahay. So, yan. So, you don't have to complicate yourself na, no? Kasi yan na, may geometry na dyan, no? Counted na yun. But for now, since, di-discuss ko naman to next chapter, no? Kung paano mag-draw ng mga ganyan. So, my task now is to draw this with the correct geometry. So, for carbon na ito, tetrahedron yan. So, kaya yung tatlong H, no? In the future, malalaman nyo rin to, no? Tapos may bent dyan, no? Okay, so, ang pangit din pala ng drawing ko. Wait lang, ayusin ko nga, nakaka-stress. Ayusin ko yung drawing. Wait lang. H. Tapos naka-bend to, di ba? So, kailangan naka-bend yan. Ayan, no? Malalaman nyo yung purpose ng, ano yung mga dash na yun? Ano yung dark line na yun? So, sa future, malalaman nyo yun. Okay, so this is the correct, parang ganun din yung drawing ko. Bahala na. So, this is the correct geometry for this molecule, no? Yung CH3OCH3. Now, for us to identify if this is a polar molecule or not, no, with the correct geometry, we can assign the direction of electrons na. CH bonds here, itong mga CH bond na to, they are non-polar. So, non-polar, 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 non-polar. So, ano yung meaning nun? Wala tayong direction for electrons dyan. But look at the CO bond. This is polar, wherein oxygen will bear the partial negative charge kasi siya ay electronegative compared to carbon. Ngayon, magdodraw tayo ng direction ng electrons, no? For this band, papunta kay oxygen, no? So, yun yung direction. For this band, ang direction ay ito. It's angle na ma-form in between them, no? So, yung angle yun na mabubuo in between them, this is the net dipole, no? So, that is the net direction of your electrons, no? Okay. So, yun, kapag may angle, ganito kasi nangyayari dyan, eh. Para ito yung isang CH, tingin kayo sa camera ko, no? Ito yung CH3 sa kaliwa. Ito yung isa pang CH3 sa kaliwa. Itong nasa gitna na may oxygen. Tinutulak namin. Ito, tumutulak pa ganon. Ito, tumutulak pa ganon. So, pag sabayin ko yan, ito ba, pataas yung direction, no? Ito ganon, no? Say, ayun, no? So, nagbabalik tayo, no? So, if, sabi ko nga, no, if we have a net direction of our, electrons, no, pataas kanina, then we can say that the molecule is polar. So, that means this is polar, this is polar. Yung ammonia, na-drawing na to kanina, no? And we know that the net direction for ammonia, ito yun, no? So, may net dipole moment siya. So, that means polar siya, no? Polar. Okay. So, siguro yung for the rest of the other molecules, no? Pwede nyo i-google yung structure, no? Pag di kayo masaya sa ganitong drawing, no? Para makita nyo yung 3D shape niya. Pero, good na to, eh. Etong letter D, may isomers dyan, no? Nakainis yung converge. But anyway, so yun, no? So you can Google the shape of the isomers of CCl2Br2, no? So yun, you can determine whether that's polar or not, no? Yeah, so you have any questions, clarifications, or okay naman tayo? Baka familiar na rin kasi tayo dito, no? Diyan kami yan, eh. So, questions, clarification, or okay pa naman? Okay pa kayo, guys?
Yes po.
Sige. So, yan. So, you can, na lang, no? You can you can use Google, no, to check kung ano ba yung shape ng mga talaga to, no? You can also verify if that's polar or not, no? So, yan. Sasagutin natin yan pagka-upload ko ng answer sheets for this whole chapter, no? Sige. Punta na tayo sa last part para matapos na tayo. Tapos na yung ating buhay at paghihirap na. Okay. Intermolecular forces, Gen-Chem ulit na. So, intermolecular forces, these are the forces of attraction. Inter, meaning between different molecules. So, this one molecule and the other molecule, kumakawin na naman si Charlene. So, yun, may interaction silang dalawa. So, we have many types of intermolecular attractions or intermolecular forces. We have dipole-dipole, hydrogen bonding, and London forces or dispersion forces. No? So, yan. Those different types of interaction has something to do with the polarity of the molecule. And yan. So, with the polarity of molecule, you can predict the type of the intermolecular force present, no? So, yan. Pwede mo malaman yung type ng intermolecular force na meron yung isang molecule And with an understanding of that, no, you can predict the properties of your substances, no, such as its boiling point, no, and how it behaves with water, so on and so forth. No. Even the state of matter, you can predict that using intermolecular forces. No. So walk through lang tayo because kasama naman to sa Gen Chem, no, sa Inorg Chem. Dipole, dipole. So from the word itself, interaction siya ng dipole with another dipole. Yun nga. Look at this illustration now. So we have here this molecule, acetone, no? So ito yung acetone molecules natin, no? So kanina, nadaanan na natin to, example to eh. Nandito, acetone. Okay? So zoom natin. So we know that the oxygen side of the acetone is negative charge because of its electronegativity. Electrons are mostly found in this position. Dito sa side na walang electrons, nandun yung partial positive side. What happens is that if you have many acetone molecules, they will actually line up in such way that the negative side of one molecule is pointed to the positive side of the other molecule, no? So on and so forth, no? So, mabansin nyo, yung negative nakapoint sa positive, yung positive nakapoint sa negative, no? So they form this chain, no? The chain of plus positive side and negative side, no? Okay, so that's the dipole-dipole interaction, no? And the dipole-dipole interaction is actually strong, no? Yun. So that's why acetone exists as liquid, no? And not as a gas, no? Because of the dipole-dipole interaction, no? The stronger the interactions kasi, no, is yun, the more liquidy it is, no, or the solid it is, no. So yun. So dipole-dipole siya ay interaction between one dipole molecule and another, no. So yan. Yun lang naman yung gusto ko sabihin dyan, no. Sige. Let's look at this, no. So let's look at these two molecules. So we have isobutylene and acetone, no? Check natin. The melting point for isobutylene is negative 140. For acetone, that's negative 94. Boiling point is negative 6.9. For acetone, that's 56 degrees Celsius, no? Okay, so ano yung difference nila between the two, no? Looking at isobutylene, do we have any polar bonds here? May polar bond kaya dito? Check natin. So ano ba yung mga uri ng bonds na meron tayo sa isobutylene? We have carbon-hydrogen bond and carbon-carbon bonds, no? So yan. We know last time that carbon-hydrogen bond is non-polar. Carbon-carbon bond is non-polar. So that means there is no dipole moment for this molecule and it is non-polar. Compared to acetone, may polar side siya, no? Ito yung indicated by the dipole arrow, no? So, masasabi natin that polar molecules possesses stronger interactions as compared to non-polars, no? Given the fact that the melting point and the boiling point of this polar molecule is greater than that of the non-polar, no? Bakit ba mataas yung melting point nila? Kasi, ganito lang, no? Or bakit mataas yung boiling point nila? Ito yung logic dyan, no? Ang boiling point kasi, that is the point at which your molecules na magkatabi, they break apart, no? So, kapag hindi naman pala malakas yung interaction nila, it can boil away, no? Mag-boil away siya ng mabilis lang. Just few energy Magbo-boil na siya. So that's the idea. Pero, if strong yung interaction nila, for example, polar bonds, no? So, kapag may polar interactions dyan, mas makapit yan compared to non-polars. No? Kasi non-polar, pwede na umalis agad, no? Parang adios, no? Kaya, ay, tama, head out, no? So, alis na siya. Pero, kapag polar yan, may kapit, no? Yung positive, nakakapit sa negative, eh. So, that means it will require you more energy in order to boil it, no? In order for you to separate the atoms, no? So, that's the idea. That polar molecules possesses stronger characteristics than that of the non-polar, no? So that's why mataas ang kanyang boiling point compared to non-polar isobutylene because this molecule possesses dipole-dipole interactions. This one do not, no, yung isobutylene. So siguro take down nyo sa notes nyo that polarity causes stronger interactions between molecules, no? So kapag stronger yung interaction, mas mataas yung properties such as boiling point, no? Kasi mahirap sila paghiwalayin, no? Melting point, ganun din, mahirap din paghiwalayin yung mga molecules, no? So that's the idea. Hydrogen bonding, this is one type of a dipole-dipole interaction. But compared to other dipole-dipole interactions, this is much stronger. And sabi nga ng iba, no, according to biologists, no, without hydrogen bonding, life here on Earth is impossible. Because remember, during the time na umulan dito sa Earth, no, mainit pa yung Earth noon eh. No? So, if yung Earth, mabilis siya mag-boil off, yung water pala sa Earth, mabilis mag-boil off because of the weak interactions, siguro, hindi magkakaroon tayo ng primordial soup, no? The primordial soup is not possible to exist given the fact that the Earth's surface is quite hotter before than today, no? Kasi may mga lava vent yan, no? Mga geothermal vents, no? So, yun, no? Pero hindi, no? Mataas yung boiling point ng water. So, hindi agad nag-evaporate lahat ng tubig, no? Question, bakit kaya mataas yung boiling point ng water? Because it possesses hydrogen bonding. It is a special type of dipole-dipole interaction wherein yung positive and negative end nagdudugtungan din. No? But this is only exclusive for molecules with hydrogen bonded to nitrogen, oxygen, and fluorine. No? Sila lang yung pwedeng magganito. The question is why? The answer is still unknown. No? This is just observed phenomena. No? Na-observe nila ay ganun. Tapos yun. Kasi nagbabasa din ako ng articles about this kasi I'm thinking bakit ganito? So wala akong mabasang article na ganito kasi. No? So yun. Yung scientific articles, yung mga legit articles. No? So, hydrogen bonding is only exclusive for HN, HO, and HF. No? So, yung water, yun yung may HO. No? So, yun. So, what happens is still the same concept as the dipole-dipole. The positive end is attracted to the negative end. The positive end is attracted to the negative end. No? But the idea is special lang siya because this only exists. No? The hydrogen bonds only exist in hydrogens bonded to NOF, no? HNOF, no? So, yan. Bonded yung hydrogen sa NOF, no? Nitrogen, oxygen, and fluorine, no? So, yun lang, no? So, dipole pa rin siya. Same concept, but stronger. Okay, so yun. For example, alcohols, no? Ganun din, you have your OH molecule, your OH part for alcohols, no? They can form hydrogen bonds with the other alcohol molecules. No? Okay, so yan lang. Ano to? Ito naman, no? So, also, no, special kasi si hydrogen bonding, ano yung pwede natin gawin dito, no? So, hydrogen bonding, no? Solvents that engage in hydrogen bonding are called protic solvents, no? So, when we say protic solvents, no? These are solvents that can give off hydrogen, no? Can give off hydrogens. Ay, may payslip na rin. Salamat. Nakita ko yung email. So, yan. So, protic solvents can give off hydrogens, no? Such as acetic acid, no? Ay, nagsara yung PowerPoint. Ayaw na niya. Welcome back 2 hours ago. Ay. Saan na yun? Ito. Sige. Okay, so when we say protic solvents, ito yung kaya mag-give off ng hydrogen. No? Kasi yun nga, yung hydrogen that is being connected to the negative side of your other hydrogen bonding capable molecule. No? Ang pwede kasi mangyari doon is hilahin niya yung hydrogen. No? So, it can actually pull the hydrogen off. So, when that hydrogen is pulled, no, maging free hydrogen siya, which is called the proton, the H+, no? So yun, hence it is acidic, no? Or basic, sometimes, no? So yun. So protic kasi involved yung hydrogen, no? Pwede siya hilahin ng kabilang molecule. Pero kapag ano siya, walang hydrogen bonding, edi it is not able to be called a protic solvent. We call them aprotic, aprotic, or aprotic, no? Walang hydrogens na pwede hilahin sa oxygen or sa nitrogen, no? So, ganun. So, ano pa? Ito pa. Increasing the amount of and extent of hydrogen bonding explains why the following isomers have different boiling points, no? So, of the 3 molecules shown to you, only the 2 possesses hydrogen bonding, no? H bond, no? Then ito ay dipole lang yan, no? Okay, remember that this bond is polar, no? So polar yan, polar yan, polar yan. So ipag-add mo lahat ng directions, no? Okay? Polar, polar, may papunta doon. So the net direction is downwards, no? So dipole molecule yan. So yan. So as you can see, no? Based on boiling point data, stronger yung H bonds compared to dipole, no? Kaya nga siya special, no? Okay, so yun. And what else, no? If you increase the coverage of the hydrogen bonding, that means your molecule is capable of doing more hydrogen bonding. Ano lang meaning nun? Marami kang hydrogens bonded with NOF, no? So yun. So yun, so as you can see, naging dalawa yung hydrogen bonds dito compared dito sa isa lang. And as a result, what happened to the boiling point? Nag-increase then, no? Okay, no? So this idea is generally used, no, in our biological systems such as your DNA. So, yun, the reason why hindi tayo nag-mutate agad into zombies or what, no, is thankfully because of hydrogen bondings, no. So yung hydrogen bonds present in our nucleotide bases, no, kaya meron tayong ATGC, no, ATGC pairs, no. May mga nitrogen molecules doon that are capable of forming hydrogen bonds, no. So yan, so maraming hydrogen bonds within our DNA, no. So the boiling point of the DNA is very high. Kasi if hindi mataas yung boiling point ng ating DNA, siguro uminit lang sa Pilipinas, patay na yung DNAs natin. In result, patay na tayo. But that's not the case, no? So buhay pa rin tayo kahit mainit. So yun, no? So thanks to hydrogen bonding, the boiling point or the melting point of our DNA is high, no? Because of the special bonds na nabubuo between nitrogen, hydrogen, oxygen, hydrogen, and fluorine, hydrogen. So yun. So, yan. Punta naman tayo sa last part, no? So, kung kanina, we have dipole and we have hydrogen bonding, paano kung non-polar yung molecules? Kasi, if you can remember, yung dipole-dipole, kailangan dipole siya. Dipole molecule yan, di ba? Pag hydrogen bonding naman, ang requirement dyan is dipole din siya, and at the same time, may bond siya with hydrogen and NOF, no? Sir, paano kapag wala doon, no? Paano kapag wala na doon? Edi, we have the London Dispersion Forces. If your molecule is nonpolar, wala siyang NOF bonds with hydrogen, no? Hindi siya polar, as in wala talaga, no? No choice. Ang meron ka lang nun is the London Dispersion Forces, no? So, dispersion forces, meaning may nakadisperse sa molecule. And ano ba yung umiikot sa molecules natin? Electrons, no? So, electrons are spread out evenly in your molecules. Hence, we have this term, dispersion forces, no? Okay, so, gumagalaw-galaw yung electrons around the molecule, no? So, ayan. So, umiikot-ikot yung molecules dito. Okay. So, what do we know about electrons? Negative sila, di ba? Kunwari, itong kamay ko na to, nakikita nyo sa camera, coated yan with electrons. Itong kabilang kamay ko, this is coated with electrons. What if nagdikit sila? Kunwari, nagkaabungguan sila. What will happen to the electrons? They will
Combine.
letter R. Letter
Repel.
R yung word. Ayun, yun. They will repel, no? Para ito, marami tong electrons, nagbungguan sila. What will happen is that the electrons will be pushed away to the other side. For example, this molecule, no, it suddenly bumped with this molecule. So what happens is that the electrons on the surface will be displaced, no? Will be dispersed, no? Hence the term dispersion. Okay. So mangyayari, yung electrons na originally nandito, mapupunta sa kabilang side. Kasi may electron dito, di ba? Repulsion, di ba? So yung electrons dito, tatalon sa kabilang side. So what will happen is that there will be a partial negative side and a partial positive side as a consequence, no? But again, this is instantaneous, no? Instantaneous. Instantaneous lang yan, or meaning, saglitan lang yan. Kasi pag nagbungguan yan, maghihiwalay din yan, no? So the electrons will somehow disperse, no? Uurong sila sa kabilang side ng molecule. Pero after their separation, babalik na sila sa original, no? So what happens is that the molecules are constantly bumping to each other kasi, no? Tuloy-tuloy naman yan, maliliit yung mga molecules. So most likely, magbubungguan talaga yan, di ba? Okay. So yun, why they constantly bump with each other, they form instantaneous dipoles, no? Nagkakaroon ng partial positive and partial negative, pero nawawala din. Tapos babalik, tapos mawawala, no? Kaya nga instantaneous, no? Saglitan lang yung dipole. And yun, it can still follow the concept of the dipole interactions. Pero, very much weaker to that of the permanent dipoles, no? Yung permanent dipoles, yun yung mga polar bonds, no? Itong dispersion forces, ano lang to, instantaneous dipoles. Mabilisan lang, no? Very quick, no? Kasi nagbungguan sila. Pero nawawala din, no? So, yun. So, still, there's a possibility for them to act as dipoles, but to a very much less extent, no? So, yun yung idea, no? So, if we're going to summarize, we have three types of molecular. Ayan na. So, nagbabalik ako. So, we have three types of intermolecular forces, the dipole, hydrogen bonding, and dispersion forces. If I am going to rank them, irarank ko sila, no, from strongest to weakest. Yung corona ng strongest na kay H-bond, no. So, siya kasi yung pinakamalakas sa lahat, no. Followed by the dipole, no. And yung last would be the H-bond, no. Siya yung ba't H-bond? Mali. The last one would be the dispersion, no. Kasi dispersion is just a quick or instantaneous dipole. The dipole is the permanent dipole, no? Permanent siya because of the chemical bonds. And the strongest is the hydrogen bond, no? Okay, so yun. So yun lang yung ranking natin. So balik tayo sa, remember nyo yung ranking ha, kasi yun yung most likely lumalabas sa quiz, no? Matagal pa naman yung quiz nyo, no? So yun. Okay, so dispersion forces tayo, no? So, ayun. As you can see, as long as you increase the number of electrons in your molecule, no, mas lalong tataas yung kanyang properties such as boiling point, no. So for butane, we have certain numbers of electrons. Remember ha, yung atom, we can call that corresponds to certain number of electrons, di ba? Okay. So the number of electrons present here in butane is less than the pentane, and pentane's electrons okay, so nagbabalik tayo. Nakakainis na yung converge. So as you increase the number of electrons, so habang dumadami yung electrons, what happens to the boiling point? Tumataas, no? Because of the more chances for the more chances for the dispersion forces to happen, no? Mas maraming electrons, mas maraming bubonggoin. Hence, mas maraming instantaneous dipoles, no? What else, no? So, yun lang yung idea dyan, no? More electrons, more chances na mabunggo, more dispersion forces. Okay, so onting slides na lang tayo. Salamat. Okay, so what's next, no? The surface area of the molecule also counts, no? Ibig sabihin yung shape ng molecule, no? If the molecule shape is flat, no? Mas malaki surface area niyan kaysa sa branch, no? Para straight line yan. Mas malaki ang surface area ng straight chain compared to branch, no? Diba ginagawa natin yung mga branching last time, no? So may effect yun sa properties ng molecules, no? Kasi ganito, no? What happens is that, kasi kapag flat yung mga molecules, no? They can slide on from each other, no? Pwedeng merong sa taas, meron sa baba, meron sa gilid, no? So ganun. Ganun yung nangyayari, no? Pero if you have more branches, the shape becomes complicated, no? Kunwari, ito, I have this shape, no? Dalawa. Ayun. So, ito yung dalawang methyl kunwari, tapos ito yung propane, no? Itong kamay ko, no? So, kapag mas complicated ang molecule, the more, ayun, bahagal lang nito. Ayun, ano ba yan? Stress na yung converge. So, the more complicated the shape of your molecule is, the harder for the other molecule to bump into that, no? mahirap bungkuin yung complicated yung shape compared sa flat, no? So, the lesser the chances na magbungguan sila, the lesser dispersion forces, no? So, that's why, as you can see, the more branching, the more complicated the shape of the molecule becomes, the lesser its boiling point, no? The lesser the strength of your molecules, no? So, umihina yung kanyang temperature, bumababa yung kanyang temperature ng boiling because weaker yung interactions nila. So, yun ang idea. Eh, naka-copy-paste ko lang pala to, sorry. So, you're not going to answer this sa mga may sa PowerPoint nyo. Sa dipole moment yan. So, nagkamali ako ng copy. Ito dapat. Ito ba yun? Ito. No? So, kunwari ito. Check natin. So, let's apply the idea of intermolecular forces. No? So, ethichlorohydrin is an epoxide used in the production of plastic, epoxy glues, and resins. When ethichlorohydrin is treated with phenol, two products are formed. No? These two products can be separated via distillation. Which of the products is expected to have lower boiling points? No? So we're going to compare this molecule with this molecule. No? And let's see kung sino yung mas mababa yung boiling point, no? We can predict the boiling point depending on the types of chemical bonds that we have there and the intermolecular forces they exhibit, no? So sa number 3, let's look at the molecule. May dipole ba dito?
Yes po.
Saan kaya?
Paano ko mag-point? Yung sa
Saan?
carbon po. Tsaka
Carbon?
dito sa left side. Up. Opo. Tsaka ito. Sa baba po.
Actually, itong carbon-oxygen, ito, may dipole to, di ba? Yun. Highlight natin yung dipole dyan. So, this part of the molecule, no, that possesses dipole interactions. Pwede siya mag-dipole with the other molecules. What else? Ito din, CCl, no? Dipole din yan. Ano pa? Meron pa yung natitirang isa. Check nyo na lang. Meron pa diyang naiwang isa. So, may dipole. Ano pa pwede gawin? Medyo sneaky yung isa dyan eh. Hindi nyo nakita. Ito oh. Tingnan nyo. OH. Hydrogen bond yan, no? Maski ako nang tinignan ko yun nung una, sabi ko parang parehas lang naman sila. Yung pala may OH siya dito. So kapag may OH, it can form hydrogen bond, no? So this molecule can do dipole interactions on these parts, no? It can also form hydrogen bonds. Kaya nito mag-London forces. By default, yes yung answer. It can also do London Dispersion Forces or LDF, no? Kasi sabi nga natin, our basis only for London Dispersion Forces is the electrons. Anything with electrons possesses LDF, no? Just so happened that merong stronger than LDF. Kaya hindi siya kino-consider minsan. So more on dipole and the hydrogen bonding, no? Okay, so looking at the molecule number 3, we have the London dispersion forces for nonpolar the nonpolar bonds, no? The dipole interactions for the polar bonds here, COC, yung Cl, and the hydrogen bond. And what do we know about hydrogen bond? This is the strongest, no? So that means if your molecule possesses hydrogen bond, siya na agad, no? Parang matik siya na yung number 1. Let's look at number 3. So by default, sabi ko, everything can do London dispersion forces. No? What else can we observe with the molecule number 4? So other than London dispersion forces, it can also form anong type ng interactions? Ano pang type ng interaction meron sa 4? After neto, last 2 slides na lang. So looking at number 4, medyo similar siya with 3, di ba? You still have this polar bond, no? So yung yung polar bond na yan that can form the dipole interactions, no? Saan pa yung polar bond? Bukod dyan, ito din, ayan. So you really have to look at the molecule, ha? So tignan nyo maigi yung molecules. Ano kaya yung mga polar bonds dito? So yan. So can we form hydrogen bonds here?
No po.
No, kasi walang OH tayong nakikita, no? Walang NH, walang OH, walang HF. So that means, sino mas malakas? Number 3, number 4?
3.
So in terms of intermolecular forces, number 3 is the strongest, no? And ito yung weakest, no? So, translate natin yan into boiling points. Sino yung mas mababang boiling point? Number 3, number 4.
Ano po, sir?
Sino yung mas mababang boiling point? Si number 3 or si number 4?
Number of electrons is less than. Number 4.
Ayun. So, the answer is number 4. The molecule with the lower boiling point is number 4. Bakit, no? Kasi, it is only capable of doing London forces and dipole. As compared to the molecule number 3, it can do London forces, dipole-dipole interaction, and most especially the hydrogen bonding. The existence of this single bond na OH, yun yung reason bakit mas mataas yung boiling point niya, no? So siguro screenshot nyo na lang yan, no? So yan. So that's the importance of intermolecular forces with organic chemistry. You can predict the boiling points. You can predict the strength of the molecule depending on the chemical bonds that it possesses. No? Okay, last 2 slides. Solubility. What do we know about solubility? Like dissolves like, no? So meaning nandun, if your molecule is polar, it will dissolve polar substances. If your molecule is nonpolar, it will dissolve nonpolar substances. What if may nonpolar and polar ka? Will they dissolve each other? So the answer is no, no? They will not dissolve each other. Instead, they will form layers. For example, yung tubig at yung mantika, no? So when you mix water and oil, they do not mix, no? Because oil, they are non-polar, no? For yung mga molecules sa oil, mga non-polar molecules yan, no? If you're going to check sa Google kung ano yung kanyang structure, mapapansin nyo, puro London forces lang meron, no? As compared to water, automatically may hydrogen bonding kasi H2O yung formula. H is bonded to oxygen, so may hydrogen bonding doon, no? So yun. So if the if the polarity isn't the same, no, then they will not mix, no. So that is also important in organic chemistry, no, especially when we are in the organic reactions, no. So if you want to mix your molecule with another substance, you check first if they have the same polarity, no. Kasi if hindi sila parehas ng polarity, then hindi sila maghahalo, no. So ano naman yung science between uh, sabon, no? The science behind between ko na. The science behind sabon, the science behind detergents, no? How are they able to remove the oil from your let's say plato? So paano nila natatanggal yung oil sa plato, sa kutsara, no? Because yung soap molecules, no, or yung mga detergent molecules, they possesses two different parts, no, in one molecule. So on the first part of the molecule, you have your polar group. Ito yung C double bond O. We know that this is a polar bond. So it can form dipole interactions, no. Etong dulong part niya, this is the non-polar group, no. Also called as the hydrophobic. Hate niya yung water. Kasi ito ay capable only of doing long ayun. Ayaw pa talaga ni Converge magpatapos, no? So anyway, so the idea is that this tail, no, this non-polar tail, it is only capable of doing London dispersion forces, which is not strong enough, no, to pair with the hydrogen bonding of water. So hindi talaga sila mag-mix, no. Pero this part, the polar part or the hydrophilic, water-loving part, no, the hydrophilic part, no, can do dipole-dipole interactions with water, no. So, ano gagawin ng soap? Ano gagawin ng detergent sa inyong mamantikang materials, no? Actually, this also applies to coronavirus, no? Okay, so, bakit, no? So sa mantika muna tayo. So, your oil molecules, this consists of hydrophobic parts, no? Yung oil molecules mo. Then, ano mangyayari, no? Etong soap molecules nyo, etong kanyang hydrophobic tail, that will ayun, no? So, oil is non-polar. Then, the hydrophobic tail is non-polar. So, magmi-mix sila. Tapos, ano mangyayari? On the outer layer, you have your polar part, the hydrophilic part. Itong nasa labas, yung outer shell mo, this can interact with the water naman, no? So, hence, you can remove the oil particles from your materials, no, by just using soap or detergent, no. For coronavirus, the reason why we are asked always to wash our hands is that yung viruses kasi, they have a non-polar coating. Yung protein sa labas ng virus, yung shape ng coronavirus, no, yung nasa labas nun, non-polar yon. So, ano yung ginagawa ng soap, no? So, yung ginagawa ng soap, the hydrophobic part, no, the nonpolar part will attach to the nonpolar surface of your virus. So, kakapit yun. So, i-engulf ng soap molecule yung virus. No? So, kunwari, yan yung coronavirus. No? So, ito yung nonpolar group. So, papalibutan niya. Tapos, itong polar group, this will allow water to pull off the virus from your hands. No? That's why you have to wash your hands frequently, given that the coronavirus is more infectious today than it was before because of the mutation in its chemistry, no? In its genome sequence. No? So that ends the chapter 1, which is, ay, 3 oras din pala tayo. Parang may nakaraan lang din. So yun, so that's the ending of the chapter 1. So do you have any questions? May questions tayo? Or okay naman? Alam ko kasi feel nyo parang ay ang dami, no? Ang dami talaga natin diniscuss, no? Wala tayong magagawa, ganun talaga eh, no? But yun, no? So siguro, you can revisit all the lessons that we discussed now by watching the video recording of this session or just look at the book, no? In-upload ko naman yung textbook and the PowerPoint, no? For your reference, no? So yun, that's basically our review of Gen Chem. We're able to cover electrons, how chemical bonds are formed, and the properties of different molecules. No? So, ayun, nakakapagod na. So anyway, may questions po tayo? Or concerns? Or okay na po tayo? Ano guys, kumusta na kayo?
Medyo nalito lang sa dipole, sir.
Ano meron sa dipole?
Hindi ko naintindihan, sir.
Okay. Hindi, okay lang, no? So, ano nangyayari dito sa dipole? Di ba, ito, kunwari, looking at this molecule only. Ayan. So, looking at this molecule only, nasan yung ballpen ko? So, itong acetone ko, sabi ko kanina, ang electrons nandito kay oxygen part. So, negative yon, di ba? So, yung part ayun, so babalik tayo. Hindi lang naman isang molecule yung meron. Hindi lang naman nag-isang molecule yung meron sa solution. Marami kang molecules. For example, marami kang acetone molecules. No? So, ano gagawin nila? So, the acetone molecules will orient themselves. No? Aayusin nila yung sarili na in such way na yung negative ng isang molecule nakatutok sa positive ng isa. Parang magnet, diba? Ayun. If parehas positive yung magnet, magre-repel sila. If parehas negative, magre-repel. Pero, pag pinagtama mo yung positive and negative, magdidikit sila. The same is true for dipole molecules, no? So, yung positive ng kabilang molecule, dudugtong sa negative. So, magpo-form sila ng long chain ng dugtungan, no? Positive, negative, positive, negative, positive, negative. So, dugtong-dugtong sila, no? Para silang mga magnet, no? Yan. Think of dipole molecules as magnet, no? So, the more polar your molecule is, that means the stronger yung magnet, no? Or the stronger the dipole-dipole interaction. Ayun lang po. Ano po? May gusto pa ba i-clarify?
Wala na po.
Okay naman, no? So, I hope na sagot ko yung question mo, no? Regarding the clarification about dipole, no? Basta yan. Pag dipole, ang kwento lang niya, yung positive end ng molecule that will attach to the negative end of the other. Parang magnet, magdudugtong-dugtong ang magnet if yung positive and yung negative side niya nagkadikit, no? So, ganun din sa molecules kapag sila ay gumagawa ng dipole-dipole interaction, no? So, ganun din yung case for hydrogen bonding. So, special lang siya because may H bonded with NOF, no? Ang H bonded with NOF, ito ay polar bond, no? So, dipole pa rin yun. Pero special nga lang siya, no? So, kaya tinawag siyang hydrogen bonding. Pero they use the same concept, no? Nagdudugtong-dugtong yung molecules, the stronger their pagkakadugtong, no? Pag mas malakas yung connection nila, yung positive and yung negative connections nila, mas stronger sila as a whole, no? So, yun. Any questions or clarifications pa po?
Wala na po.
Wala na si Nicard. Si Rika, may questions pa po ba?
Wala na din po.
Okay, so sana, no, alam ko nabigla kayo sa first part ng discussion, no? Parang wow, ang daming nangyayari, no? But anyway, yung application lang naman nun is that we are able to identify the different hybridizations, no? The SP, the SP2, the SP3 hybridization. So yung first part talaga medyo mind-blowing siya, no? Kasi recent lang yung ganong understanding, eh. That is just around 1930s, no? That idea existed in the early 1930s, no? Before the World War II. Medyo new siya, no? And medyo mind-blowing. But yun, the idea is yun pa rin naman, no? So yun. So to summarize what we've done today is that we identified, no, the reasons why there is hybridization. So may hybridization because carbon wants to bond with other molecules, no, and with other atoms, no, to form different organic compounds, no. So in doing hybridization, it excites one electron from the 2s to 2p. Then, pag na-excite niya yung electron from 2s to 2p, it can form different hybridizations, no? Depending on ano yung gusto niya gamiting orbitals, no? Pwede siya mag-sp3 orbital, lahat gagamitin niya. Pwedeng sp2 orbitals, may isa siyang gagamitin para sa lone pair. Lone pair. May isa siyang itatabi pala para sa p orbital, no? Okay. Tapos pwede rin siya maging sp hybridized, no? Wherein dalawa yung itatabi niya for the p bond, for the p orbital, no? Okay, so yung sp2, sp, and sp3 orbitals, they are used to form single bonds, no? Yung ating electrons found in the p orbitals, they are used to form double bonds or triple bonds, no? In the form of pi bond, no? So sigma bond, single bond. Pi bond, pwedeng double bond or triple bond yun, no? Then, ano ginawa natin, no? From the idea of hybridization, we are able to recall the molecular geometry, no? So yun, na-recall natin yung shapes ng molecules. Then later on, we applied the concept of polarity sa shape ng molecule, no? Yung dipole moment, and yung polarity. Tapos, yun, we identified the intermolecular forces of attraction, that their polarity and their shape affects the overall property of your substance, no? So we have dipole-dipole interaction, the interaction between polar molecules or the polar bonds. Hydrogen bonding, which is the interaction between dipole bonds, no, or polar bonds that exclusively contains hydrogens bonded to nitrogen, oxygen, and fluorine. And then the London dispersion forces, this applies to everything else, no? What happens in London forces is that there is just an instantaneous formation of dipole because the molecules bump, no, to one another. Nagbubungguan sila. So as they bump, no, sa kabilang molecule, they're pushing the electron to the other side of that molecule, forming dipole or I mean the instantaneous dipole, yung mabilisang dipole lang, no? Tapos nawawala din agad, no? So yun, so ranking the intermolecular forces based on strength. So the strongest is the hydrogen bond, followed by the dipole-dipole, and lastly the London forces, no? So yun, so molecules containing hydrogen bonds are usually higher in boiling point compared to molecules that are purely dipole or purely London forces in nature, no? And then we understood, no, we just recall the idea of solid, no? Ayun, so if you want to remove your soap or any lipid compounds, no, non-polar compounds, using water, you have to use. So by next meeting, we will start with the actual organic chemistry. I think that's molecular representation. So we're going to draw molecules now. And we're going to apply all the ideas that we discussed today, no, in the future subject, in the future topics, no. So yun, so I hope na may naintindihan tayo, no, kahit paano. And yun, you can always revisit the class naman. You can watch the recording of the meeting, no? Or you can ask me questions if there are things to be clarified, no. So yun, for your task, no, this weekend, no, this long weekend is, ayun, sagutan nyo na lang yung ibang items na iniwan natin dito sa topic na to. You upload them on the discussion sa Canvas. So I already, nabala na, bulol na. I already saw Nicart's solution, no? So okay naman yung mga isomers niya. So on. So yun, upload nyo na lang sa discussions. Then on Monday, I will give you the answer key, no, sa mga activity natin. So with that, no, so I thank you very much for your participation and for your understanding sa paputol-putol na converge internet na yan, no. Sa buong Valenzuela, nawawalan eh. But anyway, so thank you very much, no. So, yan. So, salamat po. Pasensya na, inabot na tayo ng 7:41. Kala ko maaga rin tayo matutapos. But yun, so I think that's all for today, no. So, salamat po. And I'll see you